Let's see how this goes.
We're live.
Well, it says live. Cool. So this worked out after some kinks. This never done the Google Hangouts before, so this is going to be good. Now I have to mute myself. Cool. All right. So we are here with Charles Hoskinson, who is the brains behind Cardano, and I want to thank you for taking time out to talk to me. We tweeted out to you guys and asked a lot of questions to see, or people had a lot of questions, and we asked to kind of get topics from the community to talk about that I thought were worthwhile and things that people really wanted to hear. So some of these you may have gotten before, some of these you may not be at liberty to necessarily give me responses to, but I figured it'd be worth trying anyways.
Sure.
So let's get started and see how this goes. All right, so what is the main motivation for app developers to build on the Cardano blockchain instead of Ethereum? And in the same light, what would be an incentive for somebody to switch from Ethereum to Cardano once it kind of gets up and moving?
Okay, well, that's a very good question. So first, can you hear me all right? Can everybody in the live stream hear me all right?
I can hear you all right. What about you guys?
One would hope.
I think there's a little bit of a delay, probably.
Probably a little bit. All right. Well, anyway, thank you for having me on.
Of course. Thanks for coming.
So that's a very good question. So the first step you have to look at is saying, well, what is the app development experience trying to accomplish in the Ethereum ecosystem? So what Ethereum is effectively doing is it's basically a Rube Goldberg machine for verified computation. So you have some program you want to run, you have an input, and you want to get an output, but you don't necessarily want to trust a server for that type of output. So the canonical example would be something like random number generation, or basically something where the server itself has an incentive to cheat or to lie to you. So you say, well, we'll do the calculation in a replicated capacity. And if we do that, then as long as we trust the majority, the output should be correct and the computation should be correct. So effectively, it's like a trusted server, even though you don't trust any one particular node. The problem with this model is that it doesn't really reflect reality in terms of server client, and it also is horrendously expensive. Third, it requires you to use exotic languages and exotic APIs and things like that. So the developer experience is quite frankly not good. If you're a cell phone app developer, if you're building a regular web-oriented server client model, and you're basically being told, hey, throw away Amazon EC2, throw away all the databases you're used to working with, throw away all the languages you're used to working with, just throw all that away. Come use Solidity, come use Web3, come use our stuff. Oh, and by the way, it's going to be horrendously expensive and super slow. And if you build anything that's viral, a la CryptoKitties, it's going to break the entire network. So that means it's a great proof of concept. It's a great experiment. And the very fact that people are breaking the network means that it's a successful project in a certain respect. But now we've gotten to the point where we have to answer the question of where do we go from here? How do we actually take this from an experiment, from a fun ecosystem, to something that actually provides real value to application developers? So when we looked at it from that perspective, we said the first thing that we need to do is give people a really good platform to keep building apps the way that they want to build apps, which means build them in a web model, HTML5, CSS3, JavaScript, and allow them to still deploy in a server client environment if desired. Okay, that's the first step, and that's why we constructed Daedalus. Daedalus is not just a Cardano specific product. Daedalus is a platform. It's like the Android or the Windows of the cryptocurrency space. And our hope is to have dApps be one-click install, and then you look at dApps as a collection of services that they consume. If the dApp wants to live in a decentralized file system, then it's going to consume, from Siacoin or Filecoin or any of these systems. If you want to do verified computation, maybe you do that with Ethereum. Maybe you do that with the Cardano system. Maybe you do that with Hyperledger. Maybe you do that with a trusted server in your model. And then you're going to have a lot of client-side code that runs in a web model, and maybe you connect to a server that has your user accounts or proprietary personal information for each user. The point is that now you're giving somebody the freedom as an app developer to kind of decide where they want to live. So that's one component of the strategy. Okay. The second component is saying, for the things that do require that trusted computation, let's try to do that in the lowest cost way possible. And let's try to allow people to write code for that in the languages that they want to write with. So tackling the first part of it, doing it the lowest cost possible, that's why we're so vigilant about Ouroboros and what we're doing with our proof of stake research is of verifying transactions in the cheapest possible way, in the lowest cost possible way. And so our hope is that if you're going to compare Ethereum or Cardano, code to code, it's going to cost you less to run your apps on our system because of the way we've designed things.
Okay.
Now, it's also important to be able to say, hey, if you want to write a smart contract in Python or in Java or in C++ or C, there should eventually be a strategy to let you do that and use the tools that you want to use. So you as a developer don't have to go learn some wonky, strange language like Plutus or Viper or Solidity. You certainly can do that, and there's benefits to doing that. But at the end of the day, you need to be able to write things in the way you want to write them and deploy them in the way you want to deploy them. So that's why we're working so closely with runtime verification on the K framework, because what K allows us to do is write the semantics of a language once. And then once you've done that, using semantics-based compilation, it can convert a Java program or a C program or any K-defined language into something that runs on our virtual machine. Now, the final point is that there is a legacy. So backward compatibility is important.
Cool.
So what we plan on doing is having EVM backward compatibility for at least all the major things like ERC20 and so forth. So the things that have already been accomplished can very easily be ported over. We're going to give people a lot of new capabilities in our system. We're going to broaden up the app development experience, so it's a lot easier for people to deploy applications in our system than it is for competing systems. And also, as an app developer, you don't have to be back-end specific. So you don't have to say, oh God, do I deploy on Ethereum or Cardano? You first design your app, and then you make a business decision whether it makes sense for that to be on Ethereum or makes sense for that to be on Cardano and so forth. We're going to be competitive by trying to make that cost as low as possible. And then we're gradually going to add in completely new capabilities that no one else has. For example, the use of trusted hardware and multi-party computation. This is kind of the final component of it. With trusted hardware, you can do things like state channels that get unbelievable throughput. The T-Chan project out of Cornell, for example, is getting 173,000 transactions per second just off of some beta prototype stuff. Mm-hmm. And, further optimizations and other things, this should go up considerably. And the use of multi-party computation means that you can now do off-chain smart contracts. So, for example, we have two protocols we've developed. One's called Kaleidoscope and the other one's called Royale. Kaleidoscope's used for poker as a proof of concept, but this actually allows you to have a poker game with up to 15 people, all off-chain, at the latency of the users themselves. Almost all computation, all data, all consumption of resources is done off-chain. And it just uses the blockchain as a trusted bulletin board, which means that you can now run these private applications, whether it be gambling or decentralized exchange or an increasingly large library of these things in your apps, and you can use them with the user's resources, so you don't have to pay gas for them. Okay? So that's kind of the key, is to build the ecosystem. You give people a great platform, the windows of the cryptocurrency space. Then you gradually add things in so that they can pull the server client model in and use it where that makes sense. And then you say, okay, when you have new capabilities, whether that be decentralized storage or that be computation as a service, that's what Ethereum and Cardano do, or that be things like multi-party computation, they're there for you as the developer to use. And you let them do it the languages that they want to use instead of the languages we kind of cram down their throat.
Yeah, for sure. And that's funny, because down the line a bit, I had another question that somebody had asked me. If programmers who wanted to get involved, if they needed to start learning Plutus or start learning Haskell, but you sort of already answered that by saying that that's not necessarily going to be a requirement.
Right.
Programmers who wanted to get involved, if they needed to. So the next one would be for me, what was the most challenging or is the most challenging thing that you've run into or aspect part of this project that's been, I guess, the most difficult for you?
Yeah, the hardest part when you are kind of at the top in a running a cryptocurrency ecosystem is just herding cats. There are so many different constituencies, there's so many different people, and they all matter. No one doesn't matter, everybody matters. But you have to figure out, with my finite pool of resources, that's people, time, money, how do we do the most good for everybody, most utilitarian for everybody? For example, we work very closely with Cardano Foundation and Emergo, and they have a long way to go. They have a lot to do to grow and evolve and mature and become really strong, great entities. But then we also have the community. Then we have to think about the evolution of Daedalus and the Cardano protocol. There's technical debt today that needs to be resolved, like the connecting to network and other issues that some users are having.
Yeah.
But then you have to kind of balance it out with the fact that we also have Shelley to get out the door. And there's a lot of new code that's coming. And in some cases, those modules will be replaced. So, how do we balance the short term with the long term? And then there are third-party integrations. Like we work with the exchanges to help get Cardano integrated. We're working with Ledger to get Cardano on the Ledger device.
I read about that.
There are other people we haven't mentioned yet, and we'll announce in the coming months. And each and every one of them takes time. So, I care very deeply about everybody's concerns, and it breaks my heart when somebody over Twitter says, I'm having trouble connecting to the network, or somebody over Reddit says, hey, I have this issue, can you help me out? And how do we balance all of that?
Yeah.
The other hard part is being blamed for things that we have no control over and can't really do much about. For example, Bittrex has had an enormous explosion of accounts because of the appreciation of Bitcoin. And when you run a regulated entity, by definition, you have to do compliance for your customers. So when you go from this many accounts to this many accounts in a very short period of time, your compliance backend gets hammered.
Mm-hmm.
Well, that means if anybody's having any compliance issues, they've been put in a really long queue. So in some cases, they can't use the service for a long period of time. Yeah. So a lot of people who are trading ADA on Bittrex and Binance and other exchanges that have had this explosive growth, they come and complain to us that a support ticket hasn't been answered for 2 weeks or 3 weeks. And I feel their pain. I really do. I wish there's something I can do, but I understand the issues that are here, and I understand that it takes time and effort, to clear this queue out. So balancing all the needs, and also dealing with third-party needs and trying to help people out even when we don't have an obligation or ability to help people out is probably the hardest part of this project. And the other side of it is managing expectations. The problem with running a cryptocurrency is not just you're building technology, you're kind of carrying on your back the hopes and dreams of thousands of people. And they've invested more than just money into the ecosystem. They've invested a philosophy and a trust into the ecosystem. So you basically wake up every single day and say, how do I carry that trust with me and do my best for these people? And that's a huge burden, and it's a huge challenge. It's tremendously rewarding because if you accomplish great things, you've brought all these people up, you've achieved magical things. But at the same time, if you fail, if you make a mistake, by definition, you're going to let somebody down and you're going to hurt somebody.
Yeah, absolutely.
That's the burden of leadership, and that's the burden of running a cryptocurrency.
Well, that, and like you said, managing expectations. Everybody has a different thought process about how quickly things should go, or what the speed things should be, or X, Y, and Z needs to happen over a certain amount of time. And unfortunately, they don't see the other side of what you guys are working on and the issues you're running into. And so sometimes time management from their perspective can be a little skewed, as I can see based on comments on Reddit and things like that. That's right. Very interesting to see people's perceptions. All right, so what is your favorite use case for Cardano, either now or what it will be possibly capable of doing in the future?
Yeah, so we're kind of walking our way through the generations. The first generation is, can we be a reasonable currency or a reasonable transaction system, move value around? That's what the problem Bitcoin is trying to solve. The next generation is, can we be a good computation platform, the smart contract system? And that's kind of the problem that Ethereum is trying to resolve. And then the true promise of Cardano, one day in the horizon, far off in the distance when we get to the promised land, is the third generation, where we're scalable and interoperable and sustainable and so forth. So, the first question is to ask, well, which applications fall into which generations? So the question is, does Cardano make good money? And more broadly, does Bitcoin make good money? Do any cryptocurrencies at the moment make good money? And I would argue no, because they're too volatile, and also they just don't have those consumer protections put in and other such things that we've come to know and expect in the developed world. So one thing that I would love to see in the Cardano ecosystem as we build this protocol out, because remember, we're a multi-token environment. ADA is kind of the centerpiece of all these things, but eventually people are going to issue their own tokens on our system, and then we can merge stake other blockchains in the system, is for us to create some form of a value stable currency that's really useful for lending. This was one of my goals when I was working with Dan Larimer at BitShares. But basically we said, God, if we could do lending with this system, we've killed the banks. If we have value stability, we'll have, by definition, decentralized exchange. We'll have a stable store of value people can put their money into, and there's some predictability behind that. And now all of a sudden I have peer-to-peer bank for the entire world, not just for Colorado, not just for some random thing. So I would love to see in the near future, or in the horizon, us find a way to do value stable currency in relationship with ADA and Cardano and using our system. That would be, in my view, solving the first generation's promise of let's build digital cash. And
Yeah,
let's
absolutely.
people up.
Valid point.
Then for utility, for the second generation, walking our way there, I would love to see us solving this whole puzzle of how much computation needs to be done on-chain versus off-chain, and how do we build applications that are censorship resistant. So if I want to run a marketplace, or I want to run decentralized Uber, or I want to run decentralized Airbnb, I have the right to do that. And that's not going to be anchored to a server or to some company. And it's not subject to the whims and wills of some politician somewhere who thinks that intervention is the best thing ever. I would love to see the whole promise of what we tried to establish with Ethereum realized, but there's a huge amount of technology that's required. And the final part of it, that third generation, this is all about how do we become the financial stack of the developing world. This is the mission of IOHK, why we founded the company. Under the hood, we're a huge engineering company, we're a huge science company, but we wake up every day and say, there are 3 billion people who don't have a financial stack, and their world isn't as good as it could be because of it. So how do we give them something that runs on a cell phone, that is in some way independent or buffered from the existing internet? And this gives them control over their identity and their property and their money and their financial life. And it's transnational in a certain respect. So we say every day, what does the infrastructure that Cardano is laying out over the horizon need to look like for us to be able to deliver that promise to people? This is a multi-sided market as well. So many of the utilities, applications, and use cases cannot be built by IOHK or Emergo or the foundation or other people. It actually has to be built by our users. So, implicit in all of this is this idea that we have to build a really easy to use platform that's really easy to develop on top of, so that we can train thousands of people all throughout the world to become developers for this system. And those people can then build out the next generation of applications and run them in a very low cost and very safe way. And those applications can solve local problems. So those are the 3 things I would hope that over the horizon in many years that Cardano provides to the space, the utilities they provide the space, that somehow we find out a way to make it a viable cash, which means we have to do lots of transactions per second and somehow find value stability, that we become a great computation layer that is censorship immune or resistant, and it's actually useful. It's not just a toy. And then finally, that we build a platform that people can use over the long horizon to solve their own problems and become that financial stack for the world that doesn't have one.
Yeah, no, and I agree with you. And you make a good point about kind of solving the first problem, which Bitcoin set out to solve itself, and yet we haven't been able to do that because of the volatility. The whole idea was digital cash and freedom as far as money goes for people, and because people see it now as a store of value, we aren't using it really transactionally for money. Nobody's really paying anybody in Bitcoin. Everybody's kind of just holding on to it in hopes it's going to increase in value, which isn't,
we actually pay some of our employees in Bitcoin, especially our Ukrainian guys. They won't take cash. They're like, give us Bitcoin, and they're doing pretty well because.
Yeah, I'd imagine they must be. That's funny, but it is important to keep that in mind as a goal for a project, because that is definitely a hurdle we still have yet to cross, really. So. That's very, very interesting. All right. Will a masternode be possible as a option in the future? And if so, if you could give maybe a broad estimation to the amount of ADA tokens that would be required to make it sort of profitable, and or what would be the minimum?
Right. So masternode is a parlance that comes out of Dash, and I think there might be a few other coins that maintain that. But basically the idea is that if you have a certain amount of token, then you've been elevated to a different type of node if you do something with that token, like lock it or bond it or whatever, and then you have a special status, like you can vote, for example. In Dash's case, you vote Treasury, or maybe you could participate in consensus or something like that. So the way we designed the system is that we wanted the system to be as useful as possible to everybody. So Ouroboros does not require this differentiation of master nodes to normal users. It basically says, okay, you have a distribution of ADA, and some people have more, some people have less, and then you run an election that elects people into an epoch proportional to the amount of ADA that they have. So if you have 25% of the supply, on average, you'll win 25% of the slots in the epoch. Not always, it depends on how the numbers are generated, but usually over an arc of time, you'll get around 25%. Now, the first question is, what happens when your slot comes up for you to actually do something for the network? Well, you have 2 options, well, 3. You can not show up, you're a Byzantine actor in that case, or you can show up and do something wrong, you're a Byzantine actor. You can show up and construct the block, or you can delegate your right to someone else, a stake pool. So that's the closest approximation we have on the consensus side to a master node in that requirement. Now, as for the exact requirements of how will a stake pool be established, we're still kind of working on some of that, but our goal is to have some sort of on-blockchain registration, where you basically have some data about your stake pool, you have some metadata, and then we commit that to the blockchain. You pay a small fee, like a burned fee, or it goes as a transaction fee. We're still looking at the economics there. And then you'll actually have a delegation center in Daedalus. We have some GUI scamps that we put up on the roadmap, and more will come over the next few months. And then people can actually select you on a list, read your metadata, and say, oh, I love that pool, I'm going to delegate to you. So anybody can run a stake pool. They just have to register one.
Okay.
And then the basic idea is that then that stake pool is kind of the logical mapping of our version of a mining pool in a certain respect. Now, the other side of it is the sustainability components of the system. So you may have heard we have a treasury, and we plan on having votes for forking and so forth. There, we're looking at liquid democracy, like a delegated democracy system. And we actually had one of our professors, Bin Cheng, who's based out of Lancaster, do about a half-hour video kind of explaining our best thoughts on how we intend on constructing our treasury. But basically, it's the same idea there, where anybody is free to submit a ballot or submit a fork proposal, given that they have, they paid a fee and so forth. And then there's some form of a delegation system that exists for people to decide whether to approve or reject these things. Now, you can do it in a very formal way where you elect people, like a Congress, to vote yes or no, or you can do it in a liquid democracy way where you do it on a ballot-by-ballot perspective. So the video goes into much more detail about our best thoughts, and we have about a 30-page white paper that we've written that explains the cryptography, because some of the crypto is non-trivial, like additive homomorphic encryption and zero-knowledge proofs and all this other word salad of crypto. But that's our best guess right now. And so then over time, what we're going to do is gradually roll things out. And probably at the middle part of 2018, we're going to have a conference somewhere where we try to bring everybody who's involved in decentralized governance into the same room. And we'd say, this is what we got, and show us what you got. And we do show and tell for that. And our hope is that on the back of that, we can kind of make some final parameterizations. So in terms of rollout, the first thing to roll out is the stake pool and the registration system and the delegation system. And that will come with Shelley. And then shortly thereafter, the voting mechanics will come for Treasury, and the voting mechanics will come for forking. And that will probably use a somewhat similar voting system to the system that we use for delegation. But it'll be a little bit different because you're basically doing different things. One is a service where you're basically saying maintain the system, and the other one is you actually have to put some critical thought into, do I think this is a good idea or not? For example, if I want to do a quantum immune signature scheme and Bob says XMSS and Alex says dilithium, which one should we do? Should we do both, right? So that requires thought, and maybe you're not an expert there, but your best friend Jim is an expert in post-quantum crypto, and he did a postdoc at some Harvard or something. So he said, I'm going to give Jim my vote for that one because Jim is an expert, but I'm going to stick to the monetary policy questions and things like that because I know more about that than Jim does. So that's the kind of flexibility and freedom that we want to roll out gradually in our system, and it's going to be a process, and it's basically always done the same way. We're pretty boring. We write a paper. We have professors, we go through peer review, and we do a whiteboard video, and we kind of announce it well ahead of time. And then we have long, really technical discussions with the right people. And then at some point, it kind of works its way into a Cardano improvement proposal. And those will become increasingly more public because we're moving from just an IOHK development to more of a community-oriented development. And then it'll become very federated. The foundation is going to be involved, IOHK is involved, and the community will be involved, and we'll start voting on these types of things sometime in 2018.
Well, that's exciting, and I'm hoping that people will be grateful for the response, because I know that is by far and large the most consistent question that I got from people was the staking and how the weights will go and rewards and all of that stuff. So it's definitely 2018 sounds like it's going to be an exciting year for Cardano, so I'm looking forward to it.
And we should probably talk about rewards for a little bit, because I get that question a lot, and I'm very hesitant to answer it.
Go ahead.
Rewards are a super difficult topic because you actually have two levers that you can pull at the same time. One is I'm going to pay you something to maintain the blockchain, and the other is I'm going to punish you if you don't maintain the blockchain. So there's rewards and punishments. Okay, so punishments can be things like your quality of service goes down if you don't show up, or maybe you can't spend your funds for some set of time, and maybe you have to bond to participate, and if you do something wrong, you lose your bond. That's kind of what Casper and other people are talking about, and they've been thinking about that pretty deeply. Rewards are pretty simple. It's I'm going to bribe you. If you show up and do your job, I'll give you some. So the first question is, how much do you actually need to pay? And then the next question is, how much should you pay? These are different things. Now, need to pay is, in an economic equilibrium, 1 penny above balance, meaning your cost versus your profit, is good enough to get everything to run, right? But in reality, things are volatile, time is expensive, you have a small group of people, so you probably should pay a lot more. So we have a group of people at Oxford, and we're looking at, led by Elias Kosoupas. He's a Gödel Prize winner there. He's a wonderful game theorist. And basically, we're looking at this as a game. And we say, okay, well, you have a distribution. So you have an epoch, and let's say there's 2 players in this. There's H players and L players. So H players have a high probability of showing up, and L players have a low probability of showing up. And you'll probably have like a U distribution, where most people are either an H or most people are either an L, and you'll have a couple of crazy people that live in the bottom of the U. So you have this distribution. So then the question is, what is your target network efficiency? So your network efficiency is defined as the total amount of people who showed up and made slots over the total amount of slots you have. So we have 21,600 slots per epoch, and we could have a maximum of 21,600 slot leaders show up and have a perfect efficiency. But maybe you don't need that. Maybe you need 75% or something. You pick a target, and then you say, okay, well, how many H people need to show up versus L people need to show up to hit that target? And then you have 2 levers you can pull for that game to kind of balance things out. So this allows you to construct a mathematical model given certain assumptions about how the world ought to work in ideal form. And then you just kind of roll it out and see what happens. Then you also have to figure out certain things like what else ought to be incentivized. So Bitcoin is on a per block incentive basis. So basically every time a block is generated, you have a coin-based transaction. But in Cardano, we actually do a pool incentive. So at the end of the epoch, we have this big pool of inflation that's generated. And then people will show up to that pool with a proof and say, I did something beneficial for the network. Give me my chunk of that. And that could be participation in the MPC. That can be being a slot leader. But conceivably, you can consider lots of other things. Maybe I voted in the election. Okay, there's a lot of flexibility with this type of a scheme. Okay, so once you have that set up, there's also a notion of how much should people who have delegated get versus the stake pool get. And what's the balance between these 2 things?
Yeah.
So there's a lot of internal discussions about that. And the first step is to establish a mathematical foundation and a proper game that we think is reasonable. Then from there, say, okay, well, how do we parameterize that? And what do we think is good enough? So we had some initial calculations, which we said we probably, given what we've seen empirically from Bitcoin, Next, and all these other systems, if we go from, where we're at, I think we're 26 billion coins in circulation with 31 billion, including pre-mine, to 45 billion as a ceiling, that delta is probably enough to cover everything. But the reality is we probably can run a more efficient network. And that's why we're doing all the heavy lifting with modeling right now and involving, a person who actually has real experience in mechanism design and game theory, because this is not only a one-paper deal, it's going to be a multi-paper, multi-thought deal with a lot of tuning and back and forth with the community. The other thing is that there's probably some really good publications that are going to come out of this because this is an understudied science. And there's a lot of design considerations you have to think about carefully, like should the rich get richer, and what is your churn rate of your token? Also, should people be paid to do nothing? Like if I buy ADA and I delegate it, I'm not really doing a lot of work. So should I get a huge sum of money for that? Also, how much money do you want to be in circulation? So there's a monetary velocity question that comes into that as well. And so your staking mechanics can have a lot of influence on that. So we're still working our way through it, and we'll have our best answer we can by Shelley. It's probably not going to be a perfect or right answer, but there's an old saying, the enemy of good is better. So it's really important that you put your flag in the ground and say, okay, this is 1.0. I accept it's not going to be absolutely perfect, make everybody happy, but we think we can have a fully functioning system that is sustainable and could run ad nauseum with this, given some assumptions. And maybe we could be more optimal, like Bitcoin, for example, doesn't necessarily mean to print $1 million an hour, but it does. We might be able to be more optimal, but this is the best we can do for 1.0. And then the point is that you've created the models, the theory, the papers, you've gotten the academic and economic world interested in this type of stuff. And then through further iterations and further modeling, you might be able to say, actually, we can trim the tail a little bit here. We can make the system a little bit better. Furthermore, you have to understand these systems are going to scale to levels that Bitcoin has never scaled to. And things that we assume ought to be free are not going to be free. Bandwidth is one example of that. If you go to a network, like I laugh when EOS says, we 100,000 transactions per second, 1 million transactions per second. It's like, do you understand the amount of data, bandwidth you consume when you have a network of that scale? So if your core nodes have to do that, they're not mom and dad's cable internet connection. We're talking about fiber optic backbones in a data center that are required to send that kind of information, and that is not free. That will consume hundreds of thousands to millions of dollars of operational cost. So if your operational cost is in the millions for network relay, and that's currently being unincentivized, it's not being paid for in the existing network, you have to really, really think carefully about how you should construct your incentive pool. So the way we designed it with Cardano is we say at the end of the epoch, there's this pool of inflation, and then people will have claims to it, and some of which we've specified and some of which we can add in later on as our network grows and as we learn more and our models change, and we can change these ratios. That's why it's so important to have a voting system, because that can't be done by IOHK. It needs to be done at a protocol level by people voting. That's one of the concepts that Tezos has got right in my mind, and I think it's something that we can pursue.
Yeah, no, and obviously the rewards aspect is very important because it's such a large component of incentives for people to want to hold larger quantities of ADA. And then on top of it, like you said, it's gonna have to scale to an amount that we haven't seen before. So laying the groundwork and being consistent and taking your time with what's going to be the base of it is very important. So, they say patience is a virtue for a reason. So hopefully people are aware of that and a little bit more understanding of the time it's taking, and should be appreciative of the fact that you guys are putting in time and doing the peer review process and going around and doing things that haven't necessarily been done before, because it's what's going to be the most beneficial in the long run. So how confident are you that the Cardano platform will be able to scale securely once it does have widespread global adoption, comparable to like Visa and MasterCard? And when it is at that point of size, do you have any idea what the transaction times and fees might look like, or how that would play out?
Right. Okay, that's a really good question. So first you have to have a good core protocol to run everything through. So the way we design Ouroboros is a very modular protocol. Like every component of it is really flexible. You have, first off, the election for the epoch. That's called cryptographic sortition. It used to be called follow Satoshi, but Sylvia Macaulay used cryptographic sortition. So I was like, I like Macaulay more. I'm going to use his term. So that election can be biased any way you want. Right now we bias it by a percentage of ADA, but you could imagine like a quality metric which says you're a good Cardano citizen, so you have a higher chance of winning a slot because you're a good citizen over your token. So that's great because we have freedom there. Then the way you generate random numbers, currently we use a multi-party computation protocol called Scrape, and that's great, but there's better ways of doing it, and Proust introduced those, so we can swap that out. Then there's the actual epoch. So the slots right now are synchronized, so they occur every 20 seconds, and it's pretty strict. Okay. But with Proust, we actually now have semi-synchrony. So they can kind of show up in different orders, maybe one every 5 seconds. And this one shows up a little later, and this one's a little smaller. It's like we've Bob Rossed the slots. It's like a pretty little slot here, a pretty little slot here. Okay, so that's the other thing you can modify, is like you don't necessarily need that many slots, and the slots can be a variable length and so forth. Okay, well, but wait a minute, this epoch structure can run in parallel. If you can sort transactions properly and you always know what epoch to put it in, you can have an opening phase where you run many epochs in parallel and a closing where you compress all the blocks. So it's like running like 10 epochs at the same time. So if each one is only 250 transactions per second, you have 2,500 or something. Mm-hmm. And then when you want more, you run 100 epochs in parallel because you have enough committees to do that type of stuff. Also, when you're a slot leader, you can sign more than just one block. You can sign N blocks for that slot, which means you can maintain multiple blockchains at the same time. Okay. So basically, given that Ouroboros can do all these things, it's just more of a matter of gradually working our way very carefully through the theory and systematically, iteratively rolling out improvements that'll allow this protocol to kind of walk its way into a really sharded, really efficient system. So what have we done? So we started first from saying, can we match Bitcoin security in a very straw man way? So we created GKL15. Agalos did that with Nico Leonardis and also Juan Garay. And basically said, what is Bitcoin trying to accomplish? Well, what is it trying to do? It's trying to create a secure ledger. Well, what the hell is a secure ledger? What does that mean? We don't actually have a definition for it. So we created a definition for it. Great. Then proof of work actually does that. Proved back in 2015. It's good to go. The next question is, could proof of stake, under assumptions, realistic or otherwise, ever match that level of security that proof of work has? It's an open question. So the first iteration of protocol was just to answer that. And the answer is yes. Then the next step is saying, okay, well, that's an impractical protocol. There's a lot of things you have to assume to make that work. Let's gradually make it more and more and more and more and more practical. And that's exactly what we did with the 6 iterations of the Ouroboros paper and Ouroboros Prowse. And let's expand the cryptographic foundation. So we move, from property-based to simulation-based, so we're going to universal composability. And then also we're saying, can we match things like bootstrap from Genesis? So without a checkpoint, you can only know the Genesis block and be able to look at history at any time and know which chain is the right chain. We have a way of doing that we think works. And then eventually that multi-epic approach and cross-epic communications, cross-shard communications. So we're systematically working our way through it, and we're doing it in a very rigorous way, where every time we have an advancement, we publish a paper, we go through peer review, we do a formal specification of the protocol, and it gives us a really good sense that these things are working properly. Now, the bigger thing is the relationship between what needs to be on-chain and off-chain. This is where the biggest fight is occurring right now between Blockstream and Roger and the rest of the guys. The Blockstream guys say, we don't really give a shit how big the blocks are, because everything's going to be off-chain with Lightning and all these other, second level, third level protocols. Okay. And, we're kind of pursuing that in a certain respect. We're doing trusted hardware and multi-party computation. These things will allow us to scale from whatever capabilities the base ledger has to, orders of magnitude higher capabilities. But we're not as draconian as Blockstream, saying we should never change anything. The block size will gradually get larger and also run things in multiple epochs. So we've chosen kind of a middle of the ground hybrid approach for these types of things.
All right.
Now, basically, the long or the short is that we think that the first thing that needs to be done in 2018 is.
Sorry, the dog's going off like an alarm.
Oh, it's okay. Okay, so for the audience, the 2018 is all about just gradually rolling our protocol out, turning on capabilities, getting staking working, getting delegation fully working, getting the stake pool model done. And then towards the back half of 2018, it's all about saying, okay, how do we start now turning on, starting, and running these things in parallel? How do we now start turning on level 2 protocols like our version of Lightning? And our version of Raiden and so forth. And then how do we add new capabilities to our system that no systems have before that will now allow us to do things that don't necessarily require to be on-chain, but give you the same level of security and so forth. Now, implicit in all of this, there's 2 improvements we have to make that have been almost nearly totally ignored by the cryptocurrency space. One are network scale improvements. Everybody focuses on TPS and they say, oh, well, how do we get to 100,000 or 1 million? But as I mentioned previously, the problem is that you need to be able to broadcast that much data. If you have one actor or one node that has to be that center point for all of that, you have a centralized system, or you have a system that's very fragile, because that thing goes down, the whole thing dies. Imagine if like Netflix went down or something. It's like no one can watch it, right? So you have to be able to you have to be able to come up with a better way of subscribing to data feeds, sharding data about, and having a heterogeneous broadcast model. That's why we're exploring RENA, recursive internet network architecture. And it's why we're looking at a lot of peer-to-peer protocols that have been developed over the last 5-10 years with an attempt to make the internet more resilient.
Yeah.
Our hope is to gradually roll these things in 2018 and throughout 2019. And if we get these things done correctly, we feel that we can actually broadcast the amount of data our networks can have. But then the other thing is, you have this replicated database, a blockchain. Everybody loves blockchain, 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 right? It's their favorite thing in the whole wide world. But the problem is that if you actually have real utility, you're going to have a blockchain that is in the petabytes of size, eventually yottabytes of size. So tell me, who has a computer that can store that? No one. So that means that you're going to end up having one or two actors that actually have the full copy of the database. So you have to think of things like proof. You have to think of things like, how do we compress reality so that I don't necessarily have to have it, but if I see it, I know it's real and legitimate. And then you have to also figure out things about how do you chop your database apart. And this is what Sia and Filecoin and other people are thinking about. And I'm very glad to see that there's some rudimentary progress there. But it's a major focus of ours entering into 2018 and 2019 will be gradually pulling in that as infrastructure, where when you download the blockchain, you don't actually have to have the whole copy, but you still have a reasonable level of security. So our sidechain research gives us some of that, gives us great proofs to compress the chain and be able to get the same level of security as if you had the blockchain, but you only have a small representation of it. Checkpoints, if done cleverly, creatively, also give you a way of bootstrapping very quickly. But eventually, you're going to need to have a way of breaking it apart and sharding it, similar to like BitTorrent or something like that. But there's obviously Byzantine tolerance and a lot of improvements that have been localized to cryptocurrency. So that's along the short, is that you start with a good heart. Ouroboros, I think, is the best shot we have. Then after that, you gradually make that better and better so you can run in parallel. Second, you welcome overlay protocols that can gradually enhance capabilities and lower operational cost. And then you need to also iterate and refine the network side of things, storage side of things. If you do all of that stuff, I have a lot of confidence that the network can scale to billions of users. It's an open question. We're going to give it our best shot. We have some of the best scientists around. But full disclosure, it's still a hard problem.
Oh, absolutely.
And I don't like just publishing some damn paper like Plasma and saying, "Yeah, I've solved everything. This will take us to the promised land." It's like, no. Instead, it's a long journey. We might not get there. We're going to give it our best shot. We have really good guides, really good people, and we're going to work really hard at it. And that's what we're doing. And every step of the way, you get to see our progress and judge for yourself if we've actually made some improvements or not.
Yeah, and I can honestly say, in my experience and what I think the general consensus is for people is the transparency that you guys give with your roadmap and updating and being very consistent about that is much appreciated, because obviously there are other projects that aren't as forthcoming with information or about how their tech works, and it is a little concerning sometimes. So I think that although there's a lot to be done and there's a lot that you guys have ahead of yourselves, you still are doing a good job of keeping confidence in the community by sharing what you are doing, and that way everybody sort of feels like they're a part of it. And I mean, in the same light, my next question is, how is a non-technical person how can they contribute to Cardano or ADA and be a part of that?
When we started Ethereum, one of the things that I was very adamant about, and we worked with Stefan Tuwal and others on this, was the meetup group strategy. When I was part of the Ron Paul movement back in 2007, 2008, one of the magical things about that movement was that we went from like a few thousand people to several million in a very short period of time. And that was because we were able to create meetup groups in basically every state super fast and build communities around them super fast. So I said for Ethereum, let's try to get meetup groups as quickly as we can. We did it. We did it in like 2.5 months and from 5 continents. We even had a meetup group in Iran for Ethereum. And this was back in 2014. It was just unbelievable to see how fast the community grew. So it's even more vital for Cardano because Cardano is embracing blockchain-based governance. So this is not just about setting up a fan club and telling everybody what your favorite token is. This is actually going to have some discussions about what should we fund and what fork should be approved or not. So for the non-technical users, it would be really nice to see them start aggregating into community hubs, meetup groups, and things like that. And we'll certainly do our share to help them. The Cardano Foundation would share to help them. It's going to be a big priority in 2018. Another thing is, let us know what questions you have, what concerns you have, things that you'd like to know more about, and this will inform roadmap releases. This will inform transparency disclosures. This will inform just like these interviews, these Q&A things, so we can kind of broadcast these things more reliably. Also, just because somebody's non-technical doesn't mean they can't be a good user of the system. When you download Daedalus, if it's not working, send us your logs. You're now a beta test participant, and all of a sudden now we can learn something about our wallet that tells us something's wrong, for example. So I think in the future, these are things that could have the highest impact. And then what's going to end up happening is it's going to become less of a hub and spoke model and more of an actual true mesh of a project. And there's going to be tons of independent projects kind of popping their way up, just like Ethereum has done with the ERC20 revolution, where you have all these vendors doing their own things. And then people can kind of self-aggregate into the areas that they want to aggregate in. And we'd love to see lots of dApps and products and other things on Cardano. But it's a little soon for that. Maybe the next 6 months we'll have that. But
yeah, absolutely. So neither proof of stake nor on-chain governance have been fully proven at scale. What hesitations, if any, do you have about implementation?
I wouldn't say it hasn't fully proven at scale. I think that's an unfair Bitcoin maximalist way of putting things. Next has been running for since 2014, and BitShares has DPoS, Steam has DPoS, and these things are running, and they've run tons of transactions. And so we know the consensus model works. The big complaint was, is it secure, and does it have the same incentives model and bootstrap model that proof of work had? And we'd like to believe with the work we've done with Ouroboros that is the case, that it is secure, and that the incentive models can be fine-tuned so you can produce the same type of an outcome that it has. Now, what was the other part of the question? Sorry for rudely interrupting you.
Oh, no, sorry, you're all right. I just had muted myself temporarily because people, I guess, are complaining there's an echo. So what hesitations, if any, do you have around implementation once it gets to, I guess, a wider scale?
Okay. So now that's a good question. So with any cryptographic engineering, you have what's called the semantic gap. So even if you get the paper right, the paper's perfect, and you go through peer review, and hell, you've even verified the damn proofs in the paper with Isabel, and you're like, I know high order logic, fool. You're like a ninja. You're the Jedi master of writing these papers. There is a literal Grand Canyon of assumptions between your paper and your code. And your engineer is going to grab it, and they're going to say, we implemented it correctly, and it's all wrong. It works, it runs, until it doesn't, because they've messed up on the implementation. And so there's a semantic gap there. So the first challenge that we have to overcome as a project is, how do we implement cryptographic protocols in a way that removes all ambiguity, and we have the highest possible level of confidence that these things are implemented correctly within the original intent of the white paper that's gone through peer review. And that's why we're so gung-ho about formal specification and formal verification work. This is really difficult. It's not typically done in development. You see it in things like aerospace software. Like, for example, if NASA builds the Mars rover, they verify a lot of the software that's in the Mars rover. Why? Because if the Mars rover has a defect, you can't go to Mars and go kick it to reboot it. It's done. It's lost. You have to go ship another one. It's $3-4 billion or however much they spend, gone. Or in case of jet engine, if you get the blue screen of death, it falls out of the sky and everybody dies. So not a good outcome, right? So in our view, it's super important that we use the software techniques that have been developed over the last 30 years to verify that the intent has actually been followed in the code, and the code is bug-free. Now, we're not the only project to think about this in detail. Like, for example, the SEL4 microkernel project was all about saying, I have an operating system kernel. OSs are pretty important. We'd like to believe our operating system is secure and it has all the properties we care about and it can't be hacked. So how do we make sure that kernel is properly built? So they spent like 5 years and tens of millions of dollars and lots of scientists thinking about how to do that, and they built the verified kernel. Good for them. So it's a really time-consuming, expensive process. So one of our great challenges as engineers, and it's an execution risk, is figuring out, how do we not go as insane and crazy as the SEL4 guys and spend 5 years basically mentally masturbating and trying to figure out this whole thing. But let's not just write naked code. How do we be medium level assurance, where we can extract specifications in a reasonable amount of time from a protocol, white paper, and then when we write the code, we can prove a by simulation or something like that with it. And that's a hard thing. We have an ongoing project with Ouroboros Prouse. It's our first attempt. We're using Isabel and PsiCalculus and some model for Delta Q, and we think that will be reasonable enough to actually to get it done. The other challenges that makes me concerned is that people tend to run these things on insecure platforms. If I run it on a computer with malware and keyloggers, or if I run it on a cell phone that's been corrupted or something like that, then no matter how much security I bake into the design of the software, the actual operating system it's been deployed on has some way been corrupted. So this is where the use of trusted hardware is so nice, because trusted hardware, even if the underlying operating system has been corrupted or damaged, or there is malware in that, it protects you from yourself. It's hardware that can't lie. It's just going to run the way it runs. So we're thinking really carefully about, how do we eventually roll those capabilities and features in, because then we can actually give a much better user experience that's much safer for our people. But it's an ongoing challenge. I think we have the right balance, though, in terms of academic versus engineering versus formal methods. All of these things, are still in flux, but we seem to be able to consistently write papers, get them through peer review, and actually turn them into code in a reasonable amount of time. And not just for a project of this nature, but also compared to our competitors. Ethereum's been working on Casper for 3 years, and they've just recently published, I think, a 10, 15-page paper, and it doesn't even have a lot of good properties in it. We've only been working on POS for about a year and a half, and we've published 2 papers. One has gone through 6 revisions, accepted at Crypto 17. The other one's been submitted to Eurocrypt. We think we have a pretty good chance there. We have a formal spec on the way, and we've already written one version of it, deployed it in a production system that's running right now. And that's a year and a half less time. So despite the fact that we've done things in a much more rigorous way, in a much more involved way, involving academia and peer review, we seem to be able to consistently get these protocols out. Now, the protocols will increase in complexity and interdependencies, and so there will be a slowdown from that, but we're hiring more people. We're growing by leaps and bounds. So our hope is that we can kind of keep a stable rate of progress. But it's definitely a big challenge, and it's something that shouldn't be taken lightly.
No, for sure. I mean, it definitely sounds like you have a pretty good grasp on being modest about where there's issues and where things are difficult, but also kind of where you guys are going as far as finding good resolutions and kind of, doing your due diligence, do the peer review to kind of make sure that things are right. And obviously that's what's most important, is the quality as an end result. So, so this was a big one that I got frequently. How will privacy be addressed? And to take one step further, is there any possible way, at least in theory, that there will be completely anonymous transactions or anonymity within the Cardano blockchain?
Right. That's a great question. And the Monero guys asked that, and the Zcash guys asked that. And I'm like, man, you guys are right. There does need to be privacy by design. So the challenging thing about privacy is you actually don't know when you need it. Like, let's do a thought experiment. Imagine if you were in Iraq during the 1980s or 1970s. You would want to tell everybody and their uncle that you were a member of the Ba'ath Party, because that was the only way you can get a really good job, really get ahead in life. It's a one-party rule, and there's that. Same for Russia during the height of the Cold War. You say, oh yeah, I'm a big member of the Communist Party. Or in Germany during the 1930s, oh yeah, I'm a Nazi. Of course I am, right? So you'd always want to belong to that club, because that club makes your life better if you belong to it. Then suddenly that club becomes very unpopular. In Germany there was denazification. Paul Bremer of Wolfowitz had de-Baathification of Iraq. During the 90s, it wasn't so good to be a hardcore communist. Those guys weren't in the best lights. So in all those cases, you go from an environment where you are broadcasting with a big megaphone that you belong to a club, and then suddenly history changes, and now you want to hide that fact. So you really don't know ahead of time when you need to be private and when you don't need to be private. So one school of thought says make everything private by default, and then give people the ability to personally breach that privacy on a case-by-case basis for people that they want to prove things to. But they don't do it in a global sense. So that's a pretty reasonable way of going about it. And that's the Zcash and the Monero philosophy of saying make it as private as possible by default. Outside observers can't intrinsically know what's going on. And then you as the user get to be able to make that decision. Now, I'd like to move Cardano in that direction. And there are a lot of things you have to think about very carefully about what does privacy actually mean. So it's not just transactional privacy. So this notion of linkability. So for example, when Alice sends crypto to Bob, do you know that Bob has received crypto? Can you link that address to Bob? The linkability properties. So Bitcoin, you'll hear this term that's pseudonymous, where a number, a hash, it represents a person, but all the transactions are transparent. You can see them. So things like Zcash and Monero dramatically reduce linkability. It makes it much, much harder for somebody to know that it was actually Bob connected to that address. But there are other factors to think about that people don't often mention, like, for example, the amounts. So even if you can't, without a lot of effort, connect Bob to that address, you can at least create a priority queue and say, okay, well, this $1 million transaction, I really want to know who's behind that. A lot of Bitcoin went here, so I'm going to put all my investigative efforts into the highest value transaction. So you have things like confidential transactions and so forth, where they're saying, let's try to obfuscate the amount that's flowing. So not only can you not link Bob to that address, you don't even know which address has been paid the $1 million worth of Bitcoin. But then there's also, and this is something that's the least mentioned, is network level anonymity. There's a great project out of UIUC led by a guy named Pramod called Dandelion, where they're talking about how we harden the actual network layer itself so that we can obfuscate network traffic and make it harder and harder to know who's even using our network and where these transactions are origined out of and so forth. So this is kind of like a Tor notion. How do you anonymize IPs and anonymize network traffic in a certain respect? And that's real important because maybe you can use the protocol privately, but if you live in China, for example, they decide to, or because now net neutrality has been kind of breached a bit, they start deciding, you know what, we're going to deprioritize or block network traffic using your system. Okay, so you have privacy, but you can't use it because your ISP knows you're using it and prevents you from using it. So it's a great question of like, how do you enhance network scale privacy? And so I think you need to have a composition of all three of these. Now, in terms of what primitives to use, the most sophisticated and probably useful primitive are snarks. And that's what Zcash and ZeroCoin use. And there are actually a lot of thought going into how do we improve things. So I'll announce this on your show. We were going to wait a little bit, but we are going to set up a dedicated snark lab at University of Edinburgh. We're in still negotiations for the exact amounts, but it's going to be a great lab, and we're going to study snarks at a very deep and detailed level, not just for privacy applications, but also for verified computation, because we're obsessed with things like Geppetto and Pinocchio. But that lab is going to be led by a very prominent guy, and we'll be announcing him in a bit. He's leaving Microsoft Research to come join us, so in a few weeks we'll be able to.
That's very cool.
So we're real excited about that. But then we're also looking into other things like, for example, ring signatures and getting a more formal model behind the privacy primitives there. And so we've had some discussions about that. And we've also given some funding to network scale anonymity as well. And we have some ideas about how to do confidential transactions. So we're looking at all three buckets, obfuscating the amounts, obfuscating linkability, and also network anonymity. And we've even had some discussions about alternative internets to run transactions on, whether that be satellite relays or mesh nets. But that's a more of a 2019, 2020 discussion because there's more immediate priorities. So in summary, I really do care about privacy. And I think it's very important. But you know, the other side of the discussion is how do you still make it useful for the regulator and regulated entities? And that's challenging, you know, because you know, if you're a regulated business like an exchange or a bank, it's not that you're in love with the government. The problem is that they're married to you. You know, you wake up every day, they're in bed next to you. It doesn't matter how ugly they are. They're there. And you just have to say, okay, all right, we're doing it, right? They're your business partners. So basically, you have to allow compliance to occur in some case. So in that case, you need to have a way to organize attribution and metadata to provide metadata and attribution to the parties on a voluntary basis when they need it, on a one-to-one basis. So actually, this is where DRM is so cool. You know, DRM is all about saying, I'm going to give Alice or Bob the right to view my content for some period of time. Maybe that's indefinitely, or maybe that's temporarily, like when you rent an online movie. So all these capabilities are being constructed about revocable credentials or giving you something, but then being able to take it from you, right? Well, we can treat credentials the same way and metadata the same way. So you can have a business relationship with Bitstamp, and you could say, okay, Bitstamp, I'm going to give you my KYC AML data, but when I cease to be a Bitstamp customer, I can revoke that, and you no longer have access to it. So you, Bitstamp, have met your compliance requirements under Basel III and all these other things, but I, the user, am in control of my personal data. And this does not require us to breach network level anonymity for you to do that. Something you add on to the transaction that only they see and only they have access to. So these are some of the discussions that we're having of like, how can we use trusted hardware and how can we use good cryptography to provide these types of capabilities. And we think this is something that we can gradually roll out over the series of several years. And frankly, it's something that we're not going to do alone. We're going to do it via standards committees. We're going to do it by conversations with other cryptocurrencies. You know, one of the things we do at IOHK is we're not a very private company. We telegraph, but just no one seems to pay attention to us. Like, we care about privacy. So what's the first thing I did? I said, let's go work with a privacy coin. So we're actually working with Zencash right now. They're a fork of Zcash. and we're setting up a lab for this stuff. It's like we tell everybody that, we join committees, we do all these things. So we're going to gradually chip away at it. Right now, we're as anonymous as Bitcoin. That's a pretty good starting point. And over time, we'll gradually increase that, but also create a hook so that regulated businesses and governments can have their say in the matter. And then you as a customer can make decisions about who you want to share with and how you want to share and the conditions behind that sharing. And I think that's a much better world to live in than just giving all your data to Equifax and then only finding out retroactively that they're not so good at security and losing all of that and then having identity theft for the next 10 years with no recourse.
Yeah, no, I mean, and you make an interesting point about people wanting to be anonymous and having that privacy, but then also you're trying to deal with regulatory bodies and big banking, and those two things don't really go hand in hand. And so finding that happy medium is going to be interesting. And again, you still have so much coming up in 2018 and with Shelley and things that obviously anonymity for transactions aren't necessarily, I would see, as a priority so much as getting everything up off the ground, which makes...
But they are, and it's something we take seriously. And also, we look at the other side of it, which is, by the way, there's this big elephant in the room. It's called a quantum computer, and they're coming. It's like George R.R. Martin of computation. It's like quantum computing is coming, and we all feel it. It's like it's like these white walkers coming, and there's this physics wall that protects us, but the Night's Watch isn't as powerful as they used to be. So if that visual works for you. So
yeah, I got it.
So we're also talking about how do we harden our protocols against quantum computers. So that means we have to use new crypto, and also we have to model what's called a quantum adversary, an adversary that has capabilities that normal computers don't have. So we have had a lot of discussions about that. Shelley, we're going to roll out some hardening, and then our hope is over several years we can roll out more hardening. The problem is that most of the privacy primitives that people are exploring right now are potentially vulnerable to quantum computers. So that's another challenge. It's not only how do we get reasonable privacy definitions and find that right balance between privacy and attribution and metadata, but also how do we make these things future-proof so that they're not just resilient today, but they're also resilient in the future against the quantum adversary. It's very important to understand that all network traffic has to be assumed to be logged. In America, it goes to Bluffdale, Utah. There's a big NSA center there, and they have yottabytes worth of storage. And they don't archive this because they can decrypt it today. They archive it assuming that at some point in the future they can decrypt it. So even if you have privacy today and these features are great, 5 or 10 years or 20 years when quantum computers come around and they can break all these things, they can retroactively go after you for things, right? So it's super important to from a policy standpoint to have future-proofing in your cryptographic primitives. And this not only has to have the anonymity and the privacy, but it also has to be resilient against a quantum adversary and a quantum computer. And that's super hard. And so we're working on that too, but it's going to take some time.
Yeah, no, I mean, preparing for something that doesn't necessarily exist yet is, I'd imagine, very daunting as far as, having all of that stuff, having all that information out there, like you said, with Equifax, and being able to just all of a sudden realize that there was a big it's good to know that people like you in these projects, although these things aren't an issue necessarily yet with quantum resistance and quantum computers, that it is something that's being thought about.
Right.
So writing high assurance software is definitely a long-winded process. Are you concerned that during this time that the state of the art may change? And I have heard you discuss briefly like first mover advantage and how you're not too worried about that. Right. But if you could just elaborate a little bit.
That's another really good question. There's this philosophy of doing things right versus moving fast and breaking things, and you can end up having this perfect, beautiful shelter in the middle of nowhere, and everybody's already left and gone on somewhere else, in their rickety car. So what's the balance of these things? And it's also an important point to say that Bitcoin is the least advanced and least capable of all cryptocurrencies, and yet it is the market leader. So first mover advantage does certainly have a say in the matter. But the reality is we're moving from toy phase to mainstream adoption, and the vast majority of people still do not use cryptocurrencies or cannot use or acquire cryptocurrencies easily. So to say, oh my God, we only have 12 months, and if we don't solve it in that 12 months, like the market's sealed up and there's going to be a Microsoft, and we're doomed to live under crypto windows for the next decade or two, I think that's very naive. The reality is that these systems, by nature, have to be self-evolving and have to gradually work their way into the psychology and into the platforms of people. So in my view, because we have a fairly nice window of time, it's a good idea to do things the right way. You know, if you talk to Vince Cerf or Bob Connor, any of the guys who created the internet, like the other day I called John Day. John Day was one of the original internet pioneers. He's getting pretty old, but he's still pretty smart and pretty sharp guy. You know, and he lives with like this cowl of regret that design decisions that they made back in the early days have now encumbered the entire world with a suboptimal user experience. It's Brendan Eich, the same issue with JavaScript. Guy had like, what, 50 days to create a programming language that now billions of devices use and billions of people have to deal with, and it's taken many generations, iterations to try to clean up some of those sins. So given that computer science has moved on, given that we have access to some great engineers and great scientists, and given that we do have a time budget, to me, it makes a lot of sense to pursue a high assurance development methodology. And if we get it right, then we know the backbone of our system is awesome. And it's going to stay awesome for the next 4 decades or 5 decades as we move into the future. The other thing is that it also serves as a beacon for how to do software development differently. Everybody said we were insane to use Haskell. They said if you're going to use a functional language, use Scala or F# or something, use one of these intermediate or Clojure, because at least you have developers, at least you have this. If you use Haskell, you're going to have like 3 people in the world who even know how to write the software, and 2 of them are going to be busy, and one of them's an asshole. God help you. You know, and I said, no, we're going to do it. We're going to go for it. And it was like winter. It was horrible. We had a hard time finding developers. But, you know, the reality is that if you look hard enough, eventually you can find them. You lift up a rock here, and there's a guy, and there's one under the bridge, and there's a homeless guy, and you say, you clean him up a little bit, you put him in front of a keyboard, and he starts writing code. In fact, just as a side note, you know, there was a website I saw where it said programming language designer or serial killer. And one of our guys, Phil Wadler, was actually on the website. He created Haskell with the committee, and more people voted him a serial killer than a programming language designer. And I was like, wow, okay, this is the world we're living in. All right. But, you know, after you get past that initial hump, what you find is you have these amazingly creative people who have been basically ignored. They write these great books like, you know, functional data structures and so forth. And they're like, guys, there's a much better way to write software that not only is it elegant and it's beautiful like a symphony, but it's faster, it's more secure, it's 10 times more concise, and you can ship to market even more quickly than if you use Java or C++. Trust us. And they've done their homework. They've done all the effort. So it turns out that we're actually accelerating in terms of development. We actually have less technical debt in our stack than we would expect if you're using a different language. Yes, some things are kludgy like CI and Windows support and so forth, and we've gone through a lot of misery trying to make that better, but that's a one-time cost. And once you're through that and you're out the other side, eventually you're able to ship things just as quickly as JavaScript guys can. But the difference is that you can use quick check and refinement types, and you can use property testing and all these things that you just don't have or don't have well in JavaScript and Java land. And all of a sudden your software is just so much easier to read. It's so much easier to maintain. It's so much easier to work with and so forth. So, you know, I can understand the desire to move fast and break things, and I can understand the desire to do things in a super principled, rigorous way. And Cardano as a project has always been about balance. And so we already paid the hard price of kissing the sword of Haskell. And now that we've done that, you know, we've gotten all of our cuts and things like that. We're starting to learn how to wield that tool in a very effective way. And it's turning into a very precision instrument like a scalpel. And we're getting much better at it. So I think that 2018, 2019, we're going to actually write software faster than most people do. And the quality is just going to be unbelievable. And then eventually our protocols are just going to come out like a river. And it's going to be a beautiful world to live in. So that's my delusional Charles Hoskinson, I trained in mathematics way of looking at things. Maybe I'm totally wrong, you know, and I can just be kicked to the curb and we can hire somebody else to run IOHK.
Well, from what I've read, I know that either you had said it or someone else, that Haskell is just very similar to math in the way it works and the way it's functions. So it's easier to check for errors or for consistency as far as, you know, the way it's functioning, which I think is very interesting because we've obviously seen some human errors in writing different programs and the issues that we run into because of that and the weaknesses. Right. So I think it's a cool concept and an interesting way to start with using something that gives you a different skill or a different advantage, even if it's harder to start out, like you said in the beginning, you're kind of wielding that sword and getting used to it.
Right. And also running a decentralized software company is really hard too. You know, we operate in 10 countries. We have about 10 people, 100 people in the team, and we keep growing and keep scaling. And you know, we have a saying: the sun never sets on IOHK. It's true. No matter what it is, like there's always a call, there's always a concern. I don't sleep as a consequence. I've aged like 10 years and gotten fat and all these problems as a consequence of running the company. But overall, we're getting better at what we do. And we're having a heck of a lot of fun. You know, I just bought a book on AGDA. Go figure. You know, AGDA was an old woman who used to yell at me when I volunteered at the hospital. I didn't realize that it was a programming language, but apparently it is, and you can do cool things with it. So we'll see where this road takes us. I might end up being on the serial killer or programming language designer website.
Well, if you end up on that website, let me know and I'll vote for you. What do you think Cardano's interoperability is going to look like as far as like, is it going to be an interchain operability similar to like Arc and BlockNet and using like a DEX protocol like Kyber? Like, what do you think you may see usability wise?
Right. Okay, so it's really important to separate the forest from the trees there. Like, what the hell do we mean when we say interoperability? That's a buzzword. So you can break it into two buckets, and then you can further subdivide it. So the one bucket's crypto bucket, and the other bucket's legacy bucket. Now, the crypto bucket is all about saying, all right, I need to have a way of representing assets, and I need to have a way of representing knowledge about the other chains. So asset representation, we have a whole thread of research, and we're thinking about ways of like, is UTXO equivalent to accounts? And we're writing a paper on that, and formal spec for ERC20, and these types of things. So we have a way of thinking about assets in a very abstract sense that we can write proofs about. Then in terms of representation of knowledge, what you're really talking about is I have a blockchain, and I don't want to have the whole copy of the blockchain to know that information I'm getting from that chain is correct, i.e. that the tokens you're sending me actually exist and that the tokens haven't been double spent. So our research on sidechains is giving us that clarity. And so there's really two designs to that. One is the proof of work side and the other is the proof of stake side. So we've already published the proof of work paper. It's called Non-Interactive Proofs of Proof of Work. And basically what they allow you to do is to, when you do an interledger transaction, so you have a source ledger and a destination ledger and you've sent an asset over, a validator on that destination ledger is able to look at a compressed representation of that sidechain, of that other ledger, the destination ledger, the source ledger, and say, yes, this has not been double spent, and yes, these tokens do exist. Now, once you have that, it's just a matter of making the crypto more efficient and better and making these transactions a standard and getting people to support it, or in some cases, being able to engineer around the fact that some people probably will never support it. You can do that with trusted relays or other systems, and there's a lot of ideas. Like, for example, Rootstock has this issue between the Rootstock network and Bitcoin, where Bitcoin's not going to change to accommodate Rootstock, but Rootstock wants to exist and provide value to Bitcoin. So they create a dry chains as a kind of a federated mechanism to move this about. So a little bit of pragmatism and a little bit of good cryptography will allow you to resolve most, if not all, of those issues in that in the foreseeable future. And then over time, when standards emerge, and people just start adopting them and bringing them into their chain, the holdouts will give up. Then on the legacy side of things, it gets more interesting because the reality is that they have compliance needs. The reality is they have things like chargebacks. You know, they can reverse transactions, freeze funds, and so forth. And the question is, what is, you know, your best philosophical bet, or best pragmatic bet, I should say, of who's going to be the leader there, who's going to be the winner there. So, you know, the Ripple protocol, as distasteful as it is that they recently brought Ben Losky on board, they have done a great job with Interledger and you know, talking about bank interoperability and talking about how do we kind of create a bridge between the legacy financial world and the crypto world with this new protocol, right, the Ripple network. So in my view, it's probably a good idea to go chase the Interledger committee down and chase these things down and provide good hooks for metadata and good hooks for attribution, and kind of figure out how you're going to handle freezing of funds, how you're going to handle chargebacks and these types of things. And then eventually just build pipes, you know, uplinks that allow you to send value into those networks. You lose your crypto control, so you lose your privacy, you lose all of your good rules and your certainty because you're now living in Chase's world. But you know what? You want to do business with them. You want to exchange with them. So that's the reality you live in. And then my hope is that eventually networks like Ripple will evolve to the point where they act as a buffer, where maybe you don't actually have to go and play in Chase's backyard, but you still can interface with them through an intermediary protocol. So you have to be, you know, somewhat open to many ideas, and you have to be somewhat open to the fact that you cannot have an optimal solution due to the nature of the actors who are involved. And you have to also solve these things in stages. So the first thing is, let's get the crypto to crypto interoperability where it needs to be. And so our sidechains research is what's carrying that beacon, and something will gradually roll out. And we even invented a new type of fork. It's called the velvet fork. You have hard forks, soft forks, and you have something even softer. It's velvet forks, and we have a full description of that in the paper. And the velvet fork basically allows you to, without too much effort, support a type of transaction that would allow sidechains to exist efficiently. And then let's broaden it, make sure it works well in a proof of stake world, on par with a proof of work world. And now we have kind of a reasonable basis to be able to move transactions between chains. Then it's a question of how do we do these things efficiently? And there's a whole bunch of tools that exist in our bag, from MPC to trusted hardware to overlay protocols and so forth, that we can put into play that allow us to deal with multi-asset exchange efficiently and so forth. Especially if you want to prune data out. Like, for example, if you have a foreign asset enter your ledger, should you always maintain the history of that foreign asset after it's left your ledger, or just put some sort of compressed representation like a hash of the transaction history? So these are open questions that need to be solved. Some are cryptographic, some are born of pragmatism, and some are born by consensus through committee and so forth. But that's how we approach interoperability. And the other thing is there are other guys who are thinking about it. Aeon is thinking about it, and there's a dozen other guys who are thinking about it, and it's all open source, right? So, Steve Jobs used to say that, great artists steal. And so if somebody else has a better idea than we do, we're sure as hell going to take it and pull it into Cardano, because at the end of the day, we didn't sign up to solve the interoperability problem. We signed up to solve scalability and sustainability, but we recognize that the only way these systems are going to be useful is for them to be interoperable. So we view this as a community level problem, as a cryptocurrency level problem, that every single engineer, from Blockstream engineers to Ethereum engineers to Cardano engineers, we have to resolve this together. So whoever has the best idea, we're going to take it. We're going to make contributions on the cryptography side and kind of publish and broadcast our view of how it ought to be. But at the end of the day, we have to just accept what the market is going to bear, as long as it's principled. I don't want an interoperability system that says you have to surrender all your privacy and surrender all access to your rights and be subject to civil forfeiture. Maybe Ben wants that, but I don't want that, and so I won't endorse a system or try to be interoperable with systems that compel that upon their users. But I'm just one say it's a big space.
Yeah, again, with finding that the problems are different for dealing with banking and dealing with all these regulatory bodies with the legacy system and that kind of interoperability versus dealing with other cryptocurrencies. And it's interesting to see how really divisive the problems that you are facing are on both kind of sides of the spectrum there. But it is interesting. I feel like that must be frustrating. For each problem you find, you have two existing problems within that because of the two kind of functions that you're trying to work with.
Right. And there's a world of difference between, there's actually a god, a Shinto god in Japan. It's called Billiken. And Billiken is the god of things the way they ought to be, not the way the things they are. Right. So there's the world that we ought to live in, and then there's the world we actually live in. There's another book. I have a lot of books on my shelf. But this is actually Unified Financial Analysis, written by a guy named Willy Bromertz. And I feel bad for the guy because he lives in like a world of frustration. He was a central banker and a finance professor at University of Zurich. And he's just one financial collapse after another, just sitting through it, watching them happen. And he said, guys, if we do things differently with the way that banks run their back end, these things would never happen, or at least we'd be able to predict them when they're getting close and be able to intervene. So he created this thing called Project Actus, where they have a collection of 30 contracts that composably can reconstruct all of modern finance and allow you to do much, much easier risk assessment, macro and micro prudential policy, and so forth. And so he has this beautiful thing, and it's like at MIT and all these other places, and everybody agrees it's a pretty good idea, but it never gets adopted. They're like, yes, they're there, Willie. We'll go about our own way. So that's the problem with these things, that you can have the perfect MacGuffin to solve your plot problem, but unfortunately, you're just given with whatever the director gives you. Sometimes you don't have control over that.
Yeah, that is an interesting issue to run into. So this question I also wanted the answer to, but it was, again, something that I saw frequently. We know that IOHK is contracted to work with the Cardano platform until 2020. What happens after that, and kind of what was the reason the contract started from the beginning? What is the likelihood that you guys might actually split after 2020?
So it was a 5-year contract, ran from 2015 to 2020. The initial parts of the contract were just kind of figuring out how to structure everything and getting the tech where it needed to be. And then 2016 is when we started primary development and research. And it runs till 2020 because money is finite. If we had unlimited money, we could go forever. And my great grand ancestors could carry on the legacy or something. We could build giant crypto pyramids to honor the pioneers. But the reality is that the world is finite. So the reason why sustainability is a pillar in our system, and the reason why we think about treasuries, is that I have failed if I've built a system that's so centralized by 2020 that the only entity that can keep it going is IOHK. The reality is, by 2020, we should live in an environment where there are hundreds of people doing things in our ecosystem who are equally capable, or at least within their domain, equally capable of IOHK, and it's quite competitive. With Ethereum, we're already starting to see that. You have Ethereum Java, you have parity, you have what the foundation offers, and so forth, and you have a very natural, organically growing ecosystem. So with the treasury, you're kind of putting that on steroids, because it says IOHK can now go to the community and say, here's our track record, here's what we've delivered over the last few years, and we'd like to keep working on this project. And you, the community, get to decide, is it a good idea to entrust IOHK with that responsibility? Or maybe Acme Co, is better. Or maybe Vitalik decides to abandon, Ethereum and come to Cardano and build Vitalik's client. All the merrier, right? But the point is, the community should be in that position of power, because it's not a decentralized ecosystem if there's a cult of personality behind one company and one voice. We're not Apple. We're not building the iPhone here. We're trying to build decentralized infrastructure that the whole world gets to use on equal footing. And I would love to see people be better than me and competition be stronger than me, because it means I've succeeded. It means I've built something bigger than myself. And that means that when they build something, they'll build something better than themselves. And eventually the system will grow to a point where it consumes us all. So my goal is, by 2020, for there to be a hell of a lot of competition and to have a treasury. IOHK will more likely than not participate and try to extend its contract, but it'll only be extended with the community's consent. And I'm pretty sure the community will probably be in our camp. Maybe they won't.
Yeah, I think so.
I've been CEO Ethereum for a long time, but that didn't work out so well for me. So maybe there'll be a better guy, and I can go and paint. I've been watching a lot of Bob Ross lately.
Yeah, I saw that on your Twitter. I do think that is an honorable way to look at things, though, giving yourself enough time for the platform to become independent, and then allowing the community to choose to continue to work with you guys or have you on as part of the group. And that's, I don't think, the way people were seeing that agreement to the 2020. I think they were seeing it as like maybe a more negative thing with the contract. But I think your comments on it shed some light, which is important to see it from a different perspective. But it is a good thought process to have, that give the community the ability to choose who they want once the project is stable enough.
Right. And I'd love for that to be the case with Ethereum. My God, it'd be great, because then we'd start talking about key performance indicators. You'd start talking about meaningful metrics. Like, for example, what level of transparency and accountability should you have when you build software? Next month, we're going to announce a partnership with another firm as an auditor, a technical auditor of IOHK. So the Cardano Foundation is there to kind of be that standard bearer of quality for the ecosystem. So it's super important that when I write code, that somebody actually reads that code and tells the community, as an objective third-party auditor, that code is right. So next month we'll be announcing the firm that's doing that, but we have no relationship with that firm, and they're qualified Haskell experts on par with the people that we have, and on a month-by-month basis, they're going to make our lives miserable. But it's important that we have somebody who is on the other side of the table representing the interest of the ADA holders, saying, are you guys delivering the damn product? Part of that is with the weekly technical reports. Part of that is with the monthly roadmap updates. But there also needs to be qualification of claims, that the code is proper and it's well written and it's concise and it's high quality, that the scientific claims are proper. That's why we go through peer review, because the ADA holders know whenever we get accepted, for example, we just got 2 papers accepted at Financial Crypto, that now people in the academic community have looked at all that crazy math on paper, and these people who are qualified, who don't have a dog in the fight, whose day job is to make us miserable, have said, okay, you guys did something reasonable, right? And that's the standard I think that we need to demand in the cryptocurrency space, is accountability. You need to have transparency, you need to have regular communication, and you need to build power structures where when somebody does something, there's somebody checking the work who has incentives to be a proper auditor behind that work. And I hope that we can kind of roll that out, and that becomes a gold standard for all cryptocurrency projects. At the end of the day, these guys have too much money. EOS has $1 billion. Tezos has about the same. If you look at Tezos, as a brief diversion, they have a no-bid contract where they get like $85 million or $100 million to sell software to the Tezos Foundation. Whether that software is high quality, whether it's actually worth that price or not, it's there. And then what holds DLS accountable? They're at war with their own foundation. Everybody keeps saying, fire Johan, fire Johan, fire Johan. They keep saying it over and over again. Well, guess what? He has a monopoly. There are 3 board seats. Guido left, and Johan has the deciding vote. So he gets to pick Guido's successor. So he's probably there to stay and in charge of $1 billion. So you have a cult around Arthur saying he's perfect and he does nothing wrong and he knows everything and his software is going to be great. And when they launch in February, it's going to change the whole world. But after they sell that software, who's going to give them the contract to actually continue to maintain and update it? Johan, the very person they're actively trying to fire. And this is the governance crisis that our cryptocurrency space has been encumbered with, where we say everything's too complicated, everything's too hard, so we're in a faith-based technology system. I like Vitalik and Vlad, so I'm just going to trust that they're going to get it done. Here's some money, here's some prestige, here's some power, go take it. I like Arthur, so I'm going to go trust him. And let's just hope that they all figure it out. And what we're trying to do here systematically is dispel that notion. We keep saying process over people. You have technology claims. You have science claims. You have engineering claims. You have governance claims. You have use of funds claims. You have so many different claims that people are making. And what we're saying is systematically, let's start introducing power structures where there is a counterbalance, that when a claim is made, there's a verification of the claim. Just like what Ronald Reagan used to say, trust but verify. So similarly, we want to say, if I say I'm writing the best Haskell code, you need to have somebody on the other side of the table who says, oh, really? And they have every incentive to say that we aren't. And they're going to actively go out of the way to look for that. And if we can get there, then the treasury model works really, really well. Because in a funding proposal, there's now an expectation of not just the party proposing, but how is that party going to be held accountable? Who's responsible for holding that party accountable and so forth? And if we can get there, I think the entire cryptocurrency space is going to turn into something that's really, really wonderful. Because we will have a standard of excellence that's well beyond anything that you see in the day-to-day, everyday open source project world. You have funding, you have a lot of well-meaning people, you have a lot of people there to keep them honest. Things are done in stages. They're done with peer review. They're done with oversight. And there's also a notion of, did you do your job? So you retroactively look at things after it's been finished out and say, did they get an A? Did they get a B? Did they get a C? And now the community gets to decide whether to increase funding or not. Could you imagine if we ran a government this way? We could say, okay, US government, let's look at Afghanistan. Let's go look at the war in Iraq. Let's go look at how you're running healthcare. And let's see if you deserve to get any money. Could you imagine if you had that relationship with the IRS? It would just be great.
No, I can't.
Oh my God, I'd be so happy. I would be like, the IRS would come to me and say, like, we'd like some more money from you. And it'd be like, well, let's have a discussion about that. Let's talk about how you're spending what I have right now. I like this, but I don't like this. Why should I keep funding that? And that's basically what we're proposing here is to put the community in control of that and say our monetary policy should be aligned with what the community as a whole's best interest is. And let's give people some examples of how to fund things in the right way and how to create power structures that are balanced. And then overall, I think you can build a much better ecosystem out of that. That's the way the world ought to be. It's the Billiken of cryptocurrencies.
Well, I definitely think the transparency in funding and what they're doing with the funding is very important, because I know I had watched your data dash interview where you guys talked about ICOs, and I had watched your other YouTube video last night about it. And the whole craze with people getting money taken from them and it being unregulated and there being really no accountability and no responsibility is bad for people losing money, but also bad for the crypto space because it's going to make people less interested or more weary to be a part of it and more concerned. And obviously there's a much higher risk. So it's unfortunate that, regulation and things like that are kind of a necessary evil and to a certain degree. But yeah, so no, I agree with you in that sense. Let's see. So my next one is, what did you learn from working with ETH Classic? What did you take from that project that you've learned as an experience?
The first thing I learned is just the resiliency of principles. The reality is that ETC should not exist. It has no reason to exist. If you looked at it from an objective economic viewpoint, just from a apples to oranges comparison, it should have died out. First from a game theoretic equilibrium. If I give you something, you paid nothing for it, you can sell it at any price and make a profit. So it should go to zero. That's what the model should be. And there's no reason to believe it should go back up. But somehow it did. Somehow it maintained a good market. So I learned that baked into all of these things, there really is a price for principles. There really is a price for sticking to your guns and believing in something. Second, I learned that the communities are more self-assembling than we'd like to believe. The problem when you live in the academic world or you live in a hierarchical world is you tend to always believe that there needs to be this first mover. There needs to be the king who kind of pushes something along and gets it done. And if the king isn't there, it's not going to get done. But ETC is 100% community driven. All the development teams just kind of formed out of the ether. They kind of just started working on their own things and doing their own things. And for its size, scale, and the community, it's actually made great progress. It went from a cryptocurrency where more than half of the holders probably didn't want it to exist to a cryptocurrency that's kind of stepped into its own light. Now, we learned some technological things. I left Ethereum quite early on. I left in June of 2014, and most of the major protocol development happened after I left. So I was not very familiar with where they had taken the tech stack. So we built the client from scratch. We wrote it in Scala. And we learned basically all the good, the bad, and the ugly of Ethereum. And we, from that, were able to work with people and learn quite a bit about how Ethereum works and where it doesn't work. Okay, so there's some lessons there. And now there's an open question of where the ecosystem ought to go. I don't think it's wise, because everybody wants to stay on proof of work, for Ethereum Classic to try to go capture the thunder of Ethereum and win the war, and say, we finally won it. It's just like Bitcoin Cash is trying to kill Bitcoin, right? And maybe that'll happen. Maybe Roger maybe Roger has enough honey badger mojo that he's going to be able to find a way to get it done. But if you're a betting man, maybe you'd hedge a little bit there. And similarly, I don't think it's a wise idea for us to go and try to capture what Ethereum has done, but rather say, we're walking a different road now. This is really starting to look like a better form of digital gold, a better form of digital commodity, and in a certain respect, this is like the silver to Ethereum, to Bitcoin's gold. Silver is a precious metal, just like gold, but silver also has a lot of industrial use, right? So similarly, Ethereum Classic can be that type of a digital commodity. And there's plenty of things that we can do to enhance the value along that line. We can expand and upgrade proof of work. We can make proof of work more decentralized. We can add a treasury system to Ether Classic to create a self-sustaining funding model. And we can make gradual improvements to smart contract stack there as well. So we are launching our client, and throughout all 2018, IOHK is going to make some proposals, in particular for treasuries. And our hope is that those can be approved. If they are, then there's funding there for us to indefinitely be involved in Ethereum Classic. What does that do for the Cardano ecosystem? Well, it's basically a pilot program for how IOHK would be funded beyond 2020. You ask that question, say, hey, who will fund you? Well, we can show that we can maintain a development and research team off of a treasury with Ethereum Classic. We could do the exact same thing with Cardano, right? And it's a great try before you buy for our kind of an ecosystem. So we're definitely going to do that. We'd also like to roll in our sidechain scheme. There's no reason not to have it, and also can have really awesome lightweight clients. There's some new data structures we'd like to put in that make things more efficient. And but the other thing is that it's decentralized, the governance. Everything we propose, we don't have monolithic unilateral control. ETC Dev is there, the Commonwealth is there, and other people are there. They're a lot more powerful than we are in Ethereum Classic land. So we can submit an ECIP, but at the end of the day, the community is going to have to accept it. So it's also teaching us in a certain respect how to work with a federation and how to work in a case where we're not in unilateral control of the system. That's something that Ethereum hasn't learned. And it's something that I think that we need as a company to learn quite well. And my hope is in 2018 that we can gain those lessons working with Ethereum Classic. And my hope is that we can make Ethereum Classic one of the best digital commodities in the space moving throughout the years. And like Bitcoin, it's going to be something that's around that people store value in. It'll have a lot of utility, but it's not necessarily going to be the computation layer and financial stack of the entire developing world. You know, we have different vision of what's required for that, and that requires such a radical departure from Ethereum's technology and culture that I don't feel that that's prudent or wise to push into Ethereum. But you know, that's just my vision. There are so many people are now involved in that it's not going to end up that way. It's going to end up as some sort of composition of many people's visions. It's like we're painting something, and I get to paint the upper left-hand half, and then somebody else gets to paint that. And maybe I want to do a winter scene, and they're doing an autumn scene, and then the guy's doing a beach scene, and somehow we still have to have a good painting out of all this. And you know, I'm not sure how that's going to look, but it's going to be fun, and maybe Salvador Dali would buy it or something like that.
Yeah, it is interesting to think too, as you progress, your team gets bigger and there's more components and more brains and more visions and more opinions to take on. And so it is an interesting little ecosystem, I'd imagine, to work in.
Right.
So you had briefly spoken about upcoming partnerships and kind of what you're doing, but do you have anything else as far as stuff that you're excited about, people that you're talking to?
That's a good question. So we have a lot of new research centers we're going to be opening up, and university relationships we're going to be expanding in 2018. And those announcements will be made as when they're ready. Some stem around network, some stem around privacy, some stem around programming language theory, some are just more enhancements to cryptography because we need more cryptographers. You know, and we found a way to work with the academic world in a really low cost, really efficient way. And that's a win-win for both sides. Maybe they get papers and they can enhance their brand and reputation and go, you know, climb the academic food chain and get tenure, but at the same time we actually get good protocols. So there's more of that. You know, as for partnerships, we actually have had hundreds, literally hundreds of people reach out to IOHK saying, hey, I want to do a token, or I want to do some software on Cardano. And that's going to be unending as our system continues to grow. And so part of that is learning just how and when we're going to roll these things out. We have to wait for smart contracts for a lot of these things. So we ask for patience, and also a lot of this has to be handled by Emergo. That's one of their roles in the ecosystem. Emergo is kind of the closest thing we have to a consensus in the stack. So their job is to kind of build out the application layer of Cardano. There's a bit of a conflict of interest when the protocol level designer is also involved in the application level, because we can bias the development of the protocol towards our own application. So there's important to have a material separation between these two sides of the ecosystem. But I would like to see a lot of things in 2018. Like there's a lot of healthcare ventures that want to do medical data records. We have a discussion right now with the central bank, and there's some questions about what we can do there. You know, there's a lot of questions about, can we do decentralized lending? And I've mentioned those previously and so forth. And there's a lot of good ideas that we've seen. It's just a matter of picking and choosing a collection of maybe 5 or 10 that are really nice, that really showcase the platform, and using those as the anchor set. They like the launch. It's like we're building the Xbox, and you need your launch titles. You know, what should our launch titles look like to build out the ecosystem, and then getting the developer experience and the partnership experience in a way that it's really easy for people to roll things out. The other challenge is that there's a world of difference between enterprise relationships and open permissionless ledger relationships. You know, a lot of times when people come to us and say, we'd like to launch something on Cardano or Ethereum, they're actually talking about a private permissioned ledger. So it adds actually no value, in some cases reduces value, trying to deploy their application on an open system and use ADA as the underlying token for this. They should be using a private system. So we are actually going to build an enterprise version of Cardano, and we're still in discussions with Emergo, the foundation, and other partners about exactly what that needs to look like and how we're going to do it. My preference would be using Scorex, a platform that we've maintained now for 2 years with Alex Cherpanoy and Dmitry Meshkov. It's in its second version, and just dramatically enhancing our team around that, and then building out a basic Swiss Army knife of capabilities and protocols. So pull Ouroboros into it, pull Prouse into it, pull in a lot of really advanced crypto, like all of our MPC stuff. And then the play there is that you're guaranteed, if you use Cardano Enterprise, that the tokens that you use in Cardano Enterprise will be able to understand and interact with the open Cardano ledger, the ADA network. Now, where would a use case be? So if, let's say you're Blizzard Entertainment and you run World of Warcraft. I think an economist did a calculation of the size of the WoW economy. And if you could trade WoW gold, its value would be in the billions. All those WoW equipment and things like that. So could you imagine a permission ledger that runs and accounts for all of the WoW gold and all the items in World of Warcraft, and then be able to take those items and that gold and move it into the Cardano network and then sell it on an open exchange, or exchange it for ADA and then go sell it for real money? That would be a huge value driver. Maybe EVE Online would adopt that. ISK is pretty cool, right? They have their own economist on the company. So that's something I'd like to see more of with an enterprise permissionless ledger bundle, where you can say, listen, it's there when you need it. It uses DNA and common technology that's gone to Cardano, but it has additional capabilities that are specific and bespoke to your business domain need. And if you ever end up getting a token in your system, you can move that token into an open network and then trade it as a regular cryptocurrency. You can do that. And it's a guarantee that you'll have with using our technology. So that token could be shares in your company that are accounted internally until liquidity events happen and they can leave. Or it could be an in-game currency or something like that, whatever it may be. Or maybe you can imagine a utility system where you have like an energy grid and you have tokens representing your customer's share of energy or something. And you need necessarily a really secure permission ledger where the consensus nodes are controlled by the utility, because they don't want any hacks and they don't want to put the mercy of your power to an open global network that China can control. So they say we want to control that, but we do want these tokens to be able to leave and be purchased on an open marketplace. So there is a need for this permissionless juncture. The other thing is it also helps us with that interoperability testing, where we're actually now seeing the movement of value and information between a permission ledger to a permissionless ledger. So we think entering the enterprise space through that mechanism would be a really good way of doing it. Scorex would be great because it's tried, tested, and true. It's got a lot of flexibility and abstractions in it. It's also written in Scala, which is a very enterprise-friendly language. It runs on the Java virtual machine. That's something enterprise engineers are very comfortable with. And we think that we can really do a lot of work to make that turnkey. But that's an open discussion. There's a lot of things to think about there. And we're not the only player in the space. There's Hyperledger and Digital Asset and all these other people that are trying to be the best mousetrap for the new paradigm.
Well, it sounds interesting, and the discussion of all the applications is overwhelming, but I think after talking to you yesterday, I'm probably still most excited about crypto capybaras. So whenever that comes out, that would be my go-to.
I am going to personally be involved in the design of that game. I love capybaras, man. They're awesome animals. They are like the Zen masters of the animal kingdom. They lay their ducks will sit on them. They're actually one of the few creatures too that can sit next to a crocodile and the crocodile won't eat it. For some reason, they can share the same rivers, and crocodiles don't go after them. And I go on the river, crocodiles eat me in 2 minutes. But capybara, they just get along with everybody, man. They're like if a capybara wrote The Last Jedi, it would have been a great movie. This is just how capybaras go about. So crypto kitties, that's so 2nd gen. Crypto capybaras are going to be 3rd gen, and they're going to have special hats and everything.
No, I like it. You got good response from that yesterday on Twitter. I was surprised that people got such a kick out of it, but
that'll be the only takeaway from this whole interview. I didn't understand anything he said, but when he said crypto capybara, I thought.
That's funny. So could you go into detail as to when and how the remaining ADA coins will be issued, and a little bit deeper into that, how is the total amount of coins decided? That's another question I got a lot.
Right. This is the world of arbitrariness. Like, how do we get to 21 million Bitcoin? You could start at 50 per block or 100 per block or 1,000 per block if you wanted to. There's really nothing to it. It's a arbitrary number that you select. So in the case of the original distribution of ADA, at least that was less arbitrary because it was predicated upon the crowd sale. So, a price was set, tokens were sold, 80% was sold into market, and the other 20% was distributed amongst Emergo, CF, and IOHK. So, the initial distribution, 26 billion, basically lives from that set. Future ADA will be issued via inflation, just like all cryptocurrencies, and that'll be split into 2 pools. One pool is the reward pool, compensating people for services they do, whether they're a slot leader or an NPC participant or whatever else is incentivized. And then some percentage will be allocated to a treasury mechanism, similar to how Dash does a treasury or these types of things. And then that's a community's money, and people can issue ballots and get funded from that particular treasury. So that's basically how distribution works there. Now, what is the ideal monetary policy, and how should it all be done? The problem is that academia is against us in this particular case. Most economists are Keynesians or neoclassics, and they love this idea of inflation, and they love this idea of printing money, and somehow they have all these models that say that's just great, and doesn't matter how high your national debt is, and it doesn't matter, you can just always print your way out of it. Helicopter money for all. So when you enter in with a deflationary monetary system that has a monotonically decreasing inflation metric, then that's just so alien and fundamentally incompatible, because the only thing that they can hold on to is historical monetary policy in the days when we used gold and silver as money. And we suffered from deflationary shocks where you'd have reductions in consumption and all these other things that would cause recessions and hurt the economy. So historically, deflation is a bad deal, at least in an economist's mind. So when you build a money system where deflation is the property, it's the feature, not the sin, they instantly recoil and say that everything you've done is wrong and the system is bound to collapse and suffer from the deflationary spiral. And there are days in my weaker non-Austrian moments where I do kind of think about that. For example, I was at a barbecue place years ago, and I was with some guys, and we picked this barbecue place specifically because it accepted Bitcoin. And we thought it was so cool. We were going to buy some ribs and some steak with Bitcoin. I'm like, yeah, all right. And then we were eating the meal, and we were talking about the markets and everything. And he's like, I think Bitcoin's going to go up a lot, so I'm going to buy it with cash instead of Bitcoin. So it was like the whole reason we picked this restaurant was to buy something with Bitcoin. And then we're there, and we're like, yeah, it's probably going to be more valuable tomorrow, so I'm not going to use this currency to go buy it. So basically, that's like proving the deflationary spiral. It's proving the entire motivation. If you think your money's worth more tomorrow than it is today, you actually have a disincentive to consume and an incentive to save. So if your whole thing is velocity of money, your whole thing is consumption, but these systems are just terrible for that. But the problem is these economic models are quite simplistic in that they don't live with a multi-currency environment. We have never in human history lived with the ability to spend stock and bonds and airline miles and gold and on par and as easily as we lived with the ability to spend dollars. Okay, so imagine if you have a universal wallet and it has all your tokens in it. So one token represents how much gold you have, and one token represents how much silver you have, and your dollars, and your stocks, your Microsoft stock, and your CryptoKitties, and so forth. And all your things live in this portfolio. And then when you go to Starbucks, you get to decide which one of those you want to spend. Starbucks gets dollars. They always get paid in that. But then there's a market maker that lives in between. And when you spend instantaneously, they just get that money. Our economic models were never built for reality like that, where we can, with instantaneous ability, move between different currencies and different standards and be able to consume despite the fact that some assets are going up and some assets are going down and so forth. So I do think we need to reevaluate and reimagine the way monetary policy works. Now, for our case with Cardano, Cardano is just basically representing consensus in our system. It's your stake in maintaining the ledger. And then eventually it's going to be merge staking many chains. So it's the backbone of all that value. And then eventually it's going to be that unit, that bridge currency for our decentralized exchange and other things that we roll out. And eventually the token will be computational fuel and all these other things. So there'll be natural organic demand for the token. But by no sense is that token a currency. And it's going to be used like cash. And then people are going to buy stuff with it. They may, but it's subject to the same problem with tokenizing gold or any of these other things. There's disincentives for consumption. So we need to do a lot more work on monetary policy. We need to do a lot more work of what a multi-currency world looks like. We also need to understand that we're leaving the world of government monies and entering the world of private monies. We're entering the world of global standards. If you live in Ukraine, you no longer have to live with the local currency that inflates tremendously and live with capital controls. Like our Ukrainian employees, you can use Bitcoin. And they are, and they're making a fortune for that. And eventually, when we have this universal wallet, you'll have hundreds of tokens, and that you have total control and power over where you store your money in the portfolio of how you store your money. That's never been the case in human history, and it's going to have profound impacts on monetary policy. It's also going to greatly weaken national currencies which have bad monetary policy, and exacerbate it much more so, because at least they have this monopoly where they can force you to use the standard, but now you don't have to. So I think that that's the best non-answer to the question that I can give you. You know, it's first it starts with just something arbitrary. In our case, there was some reason to it, but then it's a matter of how much do you have to pay to incentivize things. So there's something there, and then the question of, well, what do you want the currency to do? If it's just a consensus backbone and a bridge currency and a computational fuel, the supply really doesn't matter as much as the demand and what can drive demand. And then you have a circular economy that forms there. But if your goal is value stability, and you want to say that year by year, the buying power of that token for some basket of goods, some consumer price index, is the same, then actually you do have to put a hell of a lot more thought into it. In this case, it's probably wise to have a different type of token with like some sort of decentralized central bank mechanic. A lot of people are thinking about that, from MakerDAO to others, and then for various degrees of success. And that's a very deep well to go down. It's something I don't think we can solve in the short term.
Well, that's interesting to kind of, as you said, a non-answer to an answer, but it does clear up. It's just a question that came up a lot, and obviously no one's really going to have the answer except you guys directly. So I figured, well, why not add it to the list? Let's see. So I have one left, and it's just sort of more of an opinionated question. Outside of obviously Cardano and possibly Ethereum Classic, what is your favorite coin or project right now that you think is has a really good future?
Well, that's a good question. I mean, there's a lot of tokens there, right? There are projects that I really want to like, but for whatever reason, I can't like them. Like I really want to like Ripple, but Ben Losky's around, so I can't like them anymore. Principles, right? I know David, all these other guys. I talk to them on a pretty regular basis, and they always send them an email saying, "Yeah, good work here, good paper here." And they hired Ben, and I'm like, "Hey, damn it, guys." So there's projects I really want to like, and then other projects that are fascinating, but I don't think they've actually solved what they've claimed they've solved. Like IOTA, for example, is a fascinating project. Sergei Popov wrote the original paper, and there's a lot of really interesting things there. But there needs to be more iteration and running in the mill before I think it's ready for prime time. So, but the whole notion of DAGs is pretty cool. So the hash graphs and the IOTAs of the world, I think, are at least starting a good conversation to have. Then there are projects that I admire just because of their damn tenacity. Litecoin and Next are examples of just tenacity coins, where there really is no reason for Litecoin to exist, but they just give Charlie and the rest of the guys credit. They just hammered themselves an ecosystem out of nothing, and it's sustainable and it's running, and it has its adherence, and they're moving forward. So you got to give them credit. Next is another example. Frankly, Next was one of those projects that could have eaten everybody's lunch if they had better leadership, and if they had just executed a little bit more elegantly. They for their time were well ahead of their time. They had a great proof of stake algorithm. They were talking about multi-asset ledgers. They had this idea of doing smart contracts. So there's always just like, they were almost there, but they just couldn't quite get there. But yet Next still has a strong community, and they still they certainly let people know their history. In terms of things I'm looking most forward to, I mean, if I like something a lot, I just build it, because I have a lot of engineers and scientists. So we have a great project right now called QAdidas that we inherited from an anonymous mathematician named Bill White. And basically, it's creating economic incentives to write math proofs. So you can take some conjecture and write a proof and get paid for it. So I have all these fantasies of being like a graduate student and saying like, wow, I could become a millionaire writing math proofs that nobody cares about, right? But it actually broadens the conversation of scientific funding in general. These treasury systems are not just let's pay developers, they're also incentives for doing research. For example, Zencash is subsidizing our grant that we gave to Dandelion, the authors behind that. So we gave them some money, and Zencash is going 50-50 with us. So the treasury of Zencash is now funding academic peer-reviewed research. So similarly, as these systems evolve and mature, you can actually end up having a new funding channel where you don't have to go to DARPA or the NSF or the European Union. You can now go through private funding and get just as much money to do open source research that doesn't have patents or IP behind it, and it's beneficial to the entire world. So, things like QAdidas are a great, very narrowly focused case study on how to resolve the needs of a particular field. And if that can be abstracted, that gets me tremendously excited. Steam is another one. It's one of those frustrating, not quite done yet currencies, but God, they got close. They got the supply side right, where they incentivized the construction of content, but they didn't get the demand side right. There's no reason to buy the token outside of speculation. So you have value leakage out of the economy. But God, if they had ads or they had some closed economy where there was an incentive to buy the token out, it's non-speculative, they probably could have killed Reddit and could have killed Facebook and the rest of these guys over an arc of time. Because you're going to a content provider who's getting a very small sliver of money and being told to take it. And if they complain about it, can be shut out of the platform, deplatformed. It's a big issue, and it's happening more prevalently. And saying now you have a permissionless, decentralized system where you can never be deplatformed, no matter how despicable you happen to be, or if you shower or not. It's pretty cool. So I think that a few more iterations, Steam is actually going to be super cool if they can get there, or if somebody can compete and get there. That'd be great. I'd love to fund some research along that line. So that's another one of those non-answers where I didn't want to commit to one particular token, but I tend to look at the world that way. Like, which ones are interesting, but they didn't solve the problem yet? Which ones do you just have to admire for their resilience and their ability to stick to something, even if it's a lost cause? And which ones are we doing ourselves that we think could actually have a huge impact and change in the world? That's one of the great humbling. Somebody asked me the other day, don't you wish you were still the CEO of Ethereum? I mean, look at how far they've gone. And I said, 6 months I was there, it was the most miserable job I had in my life. I was basically the guy in the middle between the business people and the tech people, getting just hammered and everybody threw their problems on me. Being CEO of IOHK is like the best job in the whole world. I get to be the director of DARPA. I have all these super cool research projects that are well funded, and we can work with the university and private industry, and we can just go an all-you-can-eat buffet of intellect. But then at the same time, I get to be the CEO of Microsoft. We have a very disciplined company. We can write software. We can actually have project charters and Gantt charts and deliver things. And then I also get to be a crypto politician and just go around and spread the good gospel of Satoshi and talk about how we're going to decentralize the whole world. I've never had a job like this before. I travel like 200 days a year, 250 days a year. I've been in 40 countries in the last 3 years. And I just love it. It's so much fun. So I'm internally grateful that I've been able to get myself in this position. And I'm internally grateful that every one of those tokens on CoinMarketCap, each and every one of them has something special about it. If it's not on the technology side, it's on the culture side, it's on the community side, or it's on the ability to dream about a bigger world. And that's pretty cool. That's pretty fun.
Yeah, I would have to agree with you. I kind of figured at some point you would sort of walk around it because you don't want to stick to one project or anything like that. But I agree with you. Steam is a pretty cool little website and thing that they have going on there in the currency. I have a Steam account, and I find that the problem is people, like you said, it's incentivized, but then also on top of it, people sometimes are putting up not so great posts or things that aren't quality so much as they're just looking for monetary value and
Right.
getting something for very little effort, obviously. So there's that hurdle, but they're doing a decent job.
There's going to be a person on the other side of the token. Everybody's like, "Oh my God, my token's gone to $1 billion," but you have to sell it, and so somebody has to buy it, and then you get another thing for that thing you sell it for. So where does liquidity come from? So there's a lot of smoke and mirrors with these valuations, and like when Mastercoin was the original one for that. I remember when Mastercoin came out, and at the time it had like $80 million market cap. And man, back in that day, that was big shit. You had an $80 million market cap. You're like, hey, look at my $80 million market cap, right? You found it from $500,000, and it was great. But the trading volume was like $600 a day. So if you're willing to wait a century, you could gradually divest your position out of Mastercoin. And so, you have to have for all of these tokens an incentive for somebody on the other side to buy it. That's non-speculative. Or else you've done nothing but create a Rube Goldberg Ponzi machine. You have to have a real life incentive for people to buy it. That's why we're obsessed with Cardano being the financial stack of the developing world. It's an organic, natural economy. There'll be branches that handle commerce. There'll be branches that handle infrastructure, branches that handle identity, branches that handle all these types of applications you want to run, including games. So if you have that, it's circular, it's self-sustaining, and people can live 100% in it. They can be paid in it. They can buy things in it. They can contract in it. They never have to leave and go to the local currency. Then you built something real. You don't really ever think about when do I sell it. People are saying, "Oh, Cardano is at this high thing," and I was like, I don't care. Never going to sell ADA. I don't want to sell ADA. This thing is, I want this to be the first $1 trillion cryptocurrency. I want this thing to be its own economy so strong that it's stronger than the economy of many countries combined. And then it becomes like the de facto standard platform for how these countries run their money supply. And if we accomplish that, then we've changed the world, because we've now created principles behind money. We've created principles behind economies that aren't subject to civil asset forfeiture, that aren't subject to capital controls, that aren't subject to all these sins that governments commit to their people for the sake of power. You know, one of the most deeply disturbing things, and this is another reason why I don't like the guys like Ben Losky, is when you have things like a police officer pull a drywaller over who's just been paid for 2 months worth of work, and he's got a bunch of cash in his backseat. They search the car, they take the cash, and then they say, prove that you earned it, and maybe we'll give you some of it back. In any other profession, that is theft. But apparently we just accept that as daily business. What I love about crypto is that it takes that ability to commit that sin away from the state, and it moves us to a money system where we're actually in control of our own destiny and our own fate, not just for money, but for identity, for reputation, for property rights, and these types of things. You go to any country that's war-torn, like Syria, at some point it gets to peace. They always do. And you come back, you start picking up the pieces. Who owns that plot? Who owns that land? Who owns the fountain? All the property rights have been destroyed. So now you have another war because people are fighting over what they think is rightfully theirs. And the fact that you can denationalize these things and put them into a safe place that lives in the sky is a miracle of modern technology. And that's one of the reasons why I'm in this space, is to give these types of systems to people, which necessarily means they need to scale. It necessarily means they need to talk to each other. It necessarily means they need to be self-sufficient and organically growing. And God, it's going to take a really, really long time. I'll be an old man with a white beard by the time it's all done, like Vince Cerf is. But you know, that's a good way to spend a life. It's much better than the alternative, which is just making yourself rich. What's the point? You have your Ferrari, and okay.
The Lambo.
Yeah, you have your Lambo. You know, the Huracan's a great car. Great. Does it make you justify yourself in the mirror? You all die the same way, you know. But to say that you actually changed the way the world worked and gave something better and allowed people to build real wealth, that's worthwhile. I think there's something cool there. And to say that we can use science to do it, and that we can take what we've done in the world of physics and put that into money and create natural law for money, and that we just have to follow it. That's so cool too. Like, I get asked all the time, why are you with ETC over Ethereum? You know, it's like, because principles matter. And the whole point of cryptocurrencies is that there are principles you cannot violate, even if it's inconvenient to you, even if you're going to go bankrupt. It's just like gravity. If you're a mountaineer, there's probably more than one person climbing a mountain who suddenly wished that gravity didn't apply to them, probably for a very short period of time as they're free falling. But guess what? That's just the way the world works. And because we accepted it, we built the scientific revolution around it. It gave us everything that we had and all the wonders that we had. Human beings work really well when you put them in a box and you give them some constraints. The problem with money is it's the exact opposite. It's based on facts and circumstances and the whims of wills of the masses. So people will do things in the short term that make them feel great, that in the long term poison themselves. That's why Venezuela is in the dump and all these countries fall into the dump. And so the point of cryptocurrencies is to say, let's do what physics has done to money. Let's create crypto law, and let's just agree to follow it by consensus. And we can't change it, even if it's inconvenient, even if it hurts us. But because we're doing that, we're liberated, because now we know it's fair. Now we know it's transparent. Now we know that everybody's following the same set of rules, as opposed to Bob gets a different set of rules than Alice because Bob has a lobby, and Bob is a banker, and he has connection to a special group of people. And then you have faith in the system, and then you can build from the system, and you can actually start accomplishing real things. And it's not about who won the geographic lottery. You know, it's not about who was born to the right family. And that's why I'm in this space. That's why we do what we do. And God, it's a heck of a lot of fun. Maybe we're all crazy. Maybe we all go to jail. But at least I get to say that I tried and I did something worthwhile with my time.
Well, I'd say that's a pretty honorable goal, and I don't think anybody can fault you for wanting to improve the lives of people who are, like you said, maybe just not born in the right spot, or maybe just not born to parents who are well off. And that's it is unfair that there's such a discrepancy in things like that. How are you on time? Because somebody seems to me to want to ask you about the virtual machine.
Sure. What about the virtual machine?
ask one more question about the virtual machine. So I guess maybe the context of it, or because I know that you had you got a school, like one of the higher a school that's good with tech, I guess, to help you build it or something, right? I remember reading that.
The University of Illinois Champaign is like one of the best computer science schools in the world. They're like top 5. And actually, the inventor of LLVM is the department chair at UIUC. If you want to build a VM, that's a good place to go do it. In fact, what's his name? Creator of Netscape went there. His name will come to me in a moment, but Bolt guy, Mark Andreessen, and also Max Levchin went there, and a bunch of others. There's a great campus. It's just nestled away about a 40-minute flight from Chicago, and there's just nothing to do there other than go to the university. And there's a barbecue place called Old Dog. I say those are your 2 things. You can drink and eat barbecue, or you can go to the university. But that's exactly where you go to get shit done. Because
oh yeah, for sure.
But actually, it was done by a partner called Runtime Verification, led by Gregory Rochu, and it's part of an arc of research. So the first step was, what are the sins of Ethereum? So they wrote a paper called KEVM. And basically, they wrote the first set of formal semantics for the Ethereum virtual machine. And so that basically they got the good, the bad, and the ugly of Ethereum. And then from that, we said, well, let's imagine a better VM. Let's say that we didn't have a legacy requirement. Compatibility wasn't necessarily a high priority. It was more about, let's just do things right. Let's build a better virtual machine. And that's what they built with Yella. And so it's a register-based assembly. It looks a lot like LLVM under the hood. And it's got a lot of hooks into it that came from suggestions about how to improve Ethereum based upon a lot of papers that have been written and so forth. So if you go to Runtime Verification's GitHub, all of the semantics are there. We actually have a full set of formal semantics, and they have a whole document on the design differences between Yella and the EVM. Now, in the longer term, it's more of a question of what directions do we want to take that? Well, one is make it easier to compile things to it. That's what semantics-based compilation is all about. Another direction is make it easier to verify claims about code. So if you say, hey, this code does X, Y, and Z, make it easy to write a proof for these types of things. And so there's some threads of research there. And then also, how do we shard the virtual machine and actually run it parallel? So you can run many, many smart contracts at the same time. It's not a replicated system, it's a distributed system. So there's a large research formula there. The most exciting, I think, is actually doing a K to LLVM backend, because once that's done, you actually can take Yella and run a correct by construction VM at the same speed as a native code handwritten VM. That's never been done. And so that's like original comp sci work. And Gregori's team is they're just rock stars. And we love working with them. They're some of the brightest people I've ever worked with in my life. So they're certainly doing that. And again, it's all being done out in the open. The repo's there, people can watch it. And our hope is going to testnet up the next 3-4 months to run Yella. And then once we have that, then we'll rapidly iterate with it and pull that into Cardano computation layer. And that'll run in par with SL and be merge staked. And then you can run smart contracts in Cardano. And we've successfully honored the commitment of Cardano, which is separation of accounting from computation, which is one of our goals.
Very cool. Well, I am out of questions. I don't know if there's anything that you want to add or anything you have left to say. I feel like we covered.
So I ask everybody, if you were a cookie, what type of cookie would you be?
Chocolate chip, but maybe add walnuts. I
You
feel
know,
like it's a little bit different, but it's still very good.
Yeah, I got this question from my brother. He went to medical school and he applied at a bunch of schools, and he noticed that every time, maybe it was just this year, but every medical school he interviewed at, they asked him that question somewhere in the interview. If you were a cookie, what type of cookie would you be? And I've never quite figured out what the point of the question was, but I've gotten in the habit of asking people every now and then the question, and I get a pretty large variety of answers. And the craziest of which was from this purple-haired gal when I was in Amsterdam, and she said, I'd be a cookie with scorpions baked into it. And I said,
she was creative.
Yeah, I know, right? And I was like, well, scorpions are delicious. That's probably a pretty good cookie. All right. Well, anyway, thank you so much for your time. This has been a heck of a lot of fun.
Of course. I think we covered just about everything. I hope, I'm sure there will always be more questions, but I'm sure at least they will suffice for now.
Right. Okay. Pretty cool. Thank you so much.
Cheers. Thank you.